Let's solve Unit 1 Discrete Structures and Optimization questions. Which of the following graph is or are planar? What is actually a planar graph? A graph is called planar if it can be drawn in the plane without any edges crossing. If you take all the three graphs, you have edges crossing one or the other way. If you are able to represent the same graph without any edges crossing, then that can be called as planar graph. What about A? A can be drawn in this way. So which edge is crossing? C and D is crossing. Instead of going in the midway, what we can do is we can go in a roundabout way. Here we are not worried about what kind of representation it is. We have to make sure that the edges are existing as it is. A, B edge is there, B, D edge is there, A, C edge is there, C, F edge is there. Similarly, D, E, E, F edges are there. B, F edges are connected in between and we are connecting C, D edge in roundabout way. You can represent it in this way. Otherwise, you can have A here, B, D, E, F, C here. C, D can be connected this way and B, F can be connected this way. Either way you can represent it. So definitely A is planar here. What about B? Now this will be the planar representation of B graph. So let's check whether all the edges are present. From A we have C, D, E, F. 4 edges are there from A. So from A we will check, we have C, D, E, F. 4 edges are there. So A is done. What about B? From B we are connecting to C, D and F. So from B to C, D and F. 3 edges are there. What about C? From C we are connecting to A, B, E. 3 edges are there. So from C it is A, B, E. 3 edges are there. What about D? We are connecting to A, B, F. 3 edges again. So A, B, F. 3 edges are there in D. From D. What about E? From E we are connecting to A, to F, to C. 3 edges again. So A, F, C. 3 edges are there. What about F finally? A, B, D, E. So A, B, D, E. So all the edges are represented here in another representation. So this is definitely a planar graph. One clue from the options is at a time only one graph or two graph can be planar. Since we know A and B are already planar, we need not check with C at all. We can go with option 4 as the right answer. Next question. The probability that A hits a target is 1 by 4 and the probability that B hits the target is 2 by 5. Both shoot at the target. What is the probability that at least one of them hits the target? That is, that A or B or both hit the target. What is probability of A? It is the probability that A hits the target. So this will be 1 by 4. What about probability of B? It is B hitting the target, which is 2 by 5. Now what they have asked us to find is what is the probability that at least one of them hits the target. When they say at least one, it can be A singly, B singly or both A and B. Any condition can occur. So we are going with the formula P of A union B, which is equal to P of A plus P of B minus P of A intersection B. In this formula, you have to find A union B, that is the question. We know the value of P of A and P of B. What about P of A intersection B? P of A intersection B is the probability that both A and B hit the target. Since they are independent, we can multiply both the probabilities. So P of A intersection B can be calculated as what is P of A? It is 1 by 4. What is P of B? It is 2 by 5. We can cancel 2 here. Altogether you will have 1 by 2 into 5 is 10. So P of A intersection B will be 1 by 10. Now we have the value of all these three. So we can go for P of A union B. P of A is 1 by 4. plus P of B is 2 by 5 minus P of A intersection B will be 1 by 10. When you take LCM, it will be 20. 4 into 5 will be 20. 5 into 4 is 20. So when you multiply by 4 in the numerator, 2 into 4 will give you 8. Then 10 into 2 is 20. So we will have minus 2 here. What is 5 plus 8? It is 13. 13 minus 2 is 11. So 11 by 20 will be the answer. Option number 4 will be the right answer. Next question. If x and y are elements in a group G and if x power 5 is equal to y power 3 which is equal to E is the identity element of G, then the inverse of x square into y into x power 4 into y square must be which of the following option? Let's denote the element by z is equal to x square y x power 4 y square. The inverse of z is an element that when multiplied with z gives the identity element E. When you multiply z with z inverse, you should get E here ultimately. That should give the identity element. Z inverse can be found by taking the inverse of the complete expression. When you apply inverse to these elements, you should go in the reverse order. We have to start with y square. So y square will apply this inverse individually. Then we go with x power 4. This will be applied inverse now. Then y inverse. Then x square inverse. This is how you have to apply z inverse to individual elements here. Now we have to find the inverse of the individual elements. Basically, we are having the inverse for all the elements together. Once we applied inverse inside the parenthesis, we are making it as individual elements. When you have y square inverse, you have to just swap the powers here. Y inverse of power 2. So x power 4 inverse will be x inverse power 4. What about y inverse? This will be just y inverse only. What about x square inverse? It will be x inverse the whole square. Now we will substitute these elements in the left hand side by the elements in the right hand side. So we will have z inverse is equal to y power 2 inverse will be y inverse the whole square. X power 4 inverse will be x inverse the whole power 4. Then y inverse will be as it is, so we are not changing it. What about x square inverse? It will be x inverse the whole square. Now we know x power 5 is equal to identity element E. X inverse can be taken as x power 4. How did we arrive at this? We can write x power 5 as x into x power 4. We will bring x to this side. So when you bring it to the other side, it becomes x inverse. So we are equating x inverse to x power 4. We have to substitute x inverse by x power 4. Similarly, we have y power 3 is equal to identity element. So what will be y inverse? It will be y square because y cube can be written as y into y square. When you bring y to the other side, this becomes y inverse. This is how we are making use of this particular expression to find out x inverse and y inverse values. So we have to substitute y inverse by y square. Now what is y inverse? It is y square. The outer power will stay as it is. What about x inverse? It is x power 4. The outer power will stay as it is. What about y inverse? This is nothing but just y inverse. So y inverse is y square now. Then what about x inverse? It is x power 4. So we are having the outer power as it is. Now just multiply the powers. 2 2s are 4. So this will be y power 4. Then 4 into 4 will be 16. So it is x power 16. Then we have y square. Then we have 4 into 2 as 8. So this will be x power 8. This will be the z inverse so far. Now we know x power 5 is equal to identity element and y cube is equal to identity element. We will reduce the power of x modulo 5 and the power of y modulo 3. We will work it out separately and then apply in this particular space. Let's take y power 4. When you are applying y power 4 mod 3, because for y we have y power 3, so we have to go for power of y modulo 3. When we have y 4 mod 3, what will be the value? We will have only y. So when you divide 4 by 3, the remainder is 1. So you are going with y power 1, which is y. What about x power 16? You have to use modulo 5 here to the power. So x 16 mod 5. 5 3s are 15. So you will have only x power 1. So we are taking it as x. What about y square? What is y power 2 mod 3? It is y square again, because 2 is not divisible by 3. What about x power 8? We have x power 8 mod 5. 5 ones are 5. 8 minus 5 will give 3 as the remainder. So we have x cube here. Now instead of y power 4, we have y here. Instead of x power 16, we have x here. Y square is not getting changed, so we are keeping it as it is. What about x power 8? It is x power 3 now. This will be the inverse of z. Where do we find the value matching? In option number 2. Option 2 will be the right answer. Next question. Which one of the following is not a basic solution of system of linear equation? So we are given 2 equations. Out of these 4 options, 3 options are basic solutions. 1 option is not a basic solution. What is a basic solution? A basic solution is obtained by setting some variables to 0 and solve for the remaining variables. So let's take the 2 equations. x1 plus 2x2 plus x3 is equal to 4. 2x1 plus x2 plus 5x3 is equal to 5. First we will set one variable to 0 and solve for the other 2 variables to get the basic solution. First let's take x3 as 0. What will be the first equation? x1 plus 2x2 is equal to 4. What about the second equation? 2x1 plus x2 is equal to 5. So these 2 equations has to be solved first. We can multiply this equation by 2. This will be 2x1 plus 4x2 is equal to 8. Then we have 2x1 plus x2 is equal to 5. We have to subtract these equations. We will cancel these 2 terms. 4 minus 1 will give 3x2. 8 minus 5 will give 3. What is the value of x2? It is 1. What about x1 from this? We will take the first equation. x1 plus 2 into 1 is equal to 4. x1 is equal to 4 minus 2. So x1 is equal to 2. We have x1 is equal to 2 and x2 is equal to 1 from this particular set of equation. 2 and 1 are there as solution in option 2. So this is definitely a basic solution. What about the next case? We have to set x2 to 0. So let's have x1 plus x3 is equal to 4. 2x1 plus 5x3 is equal to 5. We have to solve for these 2 equations now. We can again multiply this by 2. Then we have 2x1 plus 5x3 which is equal to 5. So when you subtract, you can cancel x1 here. What about 2 minus 5? It is minus 3x3 equal to 8 minus 5 is 3. From this we get the value x3 is equal to minus 1. Now substitute x1 minus 1 is equal to 4. Then we have x1 is equal to 4 plus 1. So x1 is equal to 5. We have x1 is equal to 5 and x3 is equal to minus 1. 5 and minus 1 are available in option 3. This is also a basic solution. What about the third case? We have to set x1 to 0. So this will be 2x2 plus x3 which is equal to 4. Then x2 plus 5x3 which is equal to 5. Let's solve for these 2 equations. We can multiply this second equation by 2. So this will stay as it is. 2x2 plus x3 is equal to 4. 2 into x2 plus 2 into 5 will give 10x3, which is equal to 2 into 5 will give 10 here. Just go for subtraction. X2 will go. 1 minus 10 will be minus 9x3, which is equal to 4 minus 10 will be minus 6. Minus and minus will get cancelled. X3 is equal to 6 by 9. When you cancel by 3, you have 3 into 2 as 6 and 3 into 3 as 9. So x3 will have a value of 2 by 3. Now we will substitute in 2x2 plus 2 by 3 is equal to 4. 2x2 will be 4 minus 2 by 3. When you take LCM, it is 4 into 3 is 12. 12 minus 2 by 3, which will give 10 by 3. Now x2 will be 10 by 3 divided by 2 here. So this will go to the denominator. So this is divided by 2. 2 and 10 will get cancelled for 5. So x2 will be having the value of 5 by 3. x2 is equal to 5 by 3 and x3 is equal to 2 by 3. We are having this basic solution in option 4. What is the left out answer here? Option 1. So option 1 will not be the basic solution of the given system of linear equation. For basic solution, you have to set one variable to 0 and then solve for the other variables. When they have given all the three variables together, even without computing for all these three cases, you can just say that this is not a basic solution based on the number of variables present. Next question. Arrange the following graph on the basis of number of edges in increasing order. They have given n greater than 3. N is nothing but the number of vertices. Kn complete graph. The number of edges of Kn will be n into n minus 1 by 2. This is option A. This is option B. This is C. This is D. And this is E. What about cycle graph? It is just n. What about wheel graph? 2 into n minus 1. What about complete bipartite graphs? Actually, when you have bipartite graph as k of m comma n, the number of edges will be m into n. Since they have given n comma n, we are just going with n into n and making it as n square here. What about qn, n cubes graph? It will be n into 2 power n minus 1. We will substitute some values and see. For n is equal to 4. 4 into 4 minus 1 is 3. 4 into 3 is 12. 12 divided by 2 will give you 6. Then n is equal to 4 is given as it is. 2 into 4 minus 1 is 3, which will give you 6. N square is 4 square, it is 16. Then we have 2 power n minus 1 is 2 power 3, 8. 8 into 4 will give you 32. Similarly, for n is equal to 5, we are having 10 edges in A, 5 edges in B, 8 edges in C, 25 edges in D and 80 edges in E. You can calculate and see. I have already computed it and then given you here. When n is equal to 6, A has 15 edges, B has 6 edges, C has 10 edges, D has 36 edges and E has 192 edges. From here what you can understand is B will be having the least number of edges. We have to arrange it in increasing order, means ascending order. So B has the least number of edges because it is just having n edges. After B, you have a tight competition between A and C. So here it is 6 and 6, here it is 10 and 8, here it is 15 and 10. On the whole, wheel graph is having less number of edges compared to complete graph. So we are going with C, then A. What about D and E? 16, 32, 25, 80, 36, 192. So D followed by E. This will be the right order. Do we have any option with this sequence? No. That's why this question is dropped. Earlier they have given B, A, C, D as the answer. Just based on n is equal to 4, they might have given option 2. But they have given the condition here as n is greater than 3. It means not only for 4, anything above 3 it should apply. So just taking 4, you can say it can be BCA or BAC. But when you go for n is equal to 5 and 6, you should automatically get this order between A and C. Next question. A linear programming problem is as follows. Minimization problem is given here. Minimize z is equal to 30x minus 18y subject to the constraints 3x plus 4y less than or equal to 60, 5x minus 3y greater than or equal to 20 and x comma y is greater than or equal to 0. In this feasible region, the solution of LPP is or are. So either one option can be the solution or two option can be the solution. So we have to check whether A is a solution or not. If A is definitely a solution, then we can mark A and C only without checking C as per this question. So let's learn how to do it. Let's substitute the points into the constraints to see which ones satisfy all conditions. Let's take the points in A, B, C, D and E. Let's take 4, 0, 3 into 4 plus 4 into 0. This will be 3 into 4 is 12 plus 0 is 12. 12 is less than or equal to 60. What about 5x? It is 5 into 4 minus 3 into 0. 5 into 4 is 20. 20 is greater than or equal to 20. So both the constraints are done. Is x greater than or equal to 0? Yes, it is greater than or equal to 0. Y is equal to 0, so this is also satisfied. All the constraints are satisfied here, so this can be picked up for the solution. What about 2, 0? 3 into 2 plus 0, so 6 is less than or equal to 60 is fine. What about 5x? It is 5 into 2 minus 0, which will give you 10 greater than or equal to 20. Is it right? No. This constraint is failing here. X is of course greater than 0 and y is of course greater than 0. But this constraint is getting failed here. So this cannot be taken to the next level. What about 7, 5? 3 into 7 plus 4 into 5. 21 plus 20 will give 41. 41 is less than or equal to 60. Yes, it is right. What about next constraint? 5 into 7 minus 3 into 5. 35 minus 15 will give you 20. 20 is equal to 20 here. So definitely this is also fine. X is 7 and y is 5. Both are greater than 0. So this can also be considered. So if you take the option, this is A, B, C, D, E. What about 0, 15? This will be 0 plus 4 into 15. This will be 60 equal to 60. So this is satisfying because we have less than or equal to here. What about 0 minus 3 into 15? This will be minus 45 greater than or equal to 20. Here the condition is failing. So from here itself we can move away. What about 8, 5? We have 3 into 8 plus 4 into 5. 24 plus 20 will give 44 less than or equal to 60. So this is fine. What about 5 into 8 minus 3 into 5? 40 minus 15 will give 25. Is 25 greater than or equal to 20? Yes. X and y are also greater than 0 only. So this point can also be taken for solution consideration. They are asking for the solution of LPP. So we have picked up A, C, E. What we have to do to find the solution is we have to apply it in z is equal to 30x minus 18y. Whichever value is minimum, that value will be the solution. So minimization problem means you have to choose the minimum value. So let's check now. Z is equal to 30 into 4 minus 0. This will give a value of 120. So let's have 120 here. What about 7, 5? 30 into 7 minus 18 into 5. So this will be 210 minus 90. This will give you 120 as the difference. What about 8, 5? 30 into 8 minus 18 into 5. 30 into 8 will be 240 minus 90. What is 240 minus 90? It is 150. If they would have asked you for maximization, 150 should have been chosen. But since they have asked minimization, these two values will be taken as the solution. So which two points are the solution of this particular LPP? A and C. Option number 1, A and C only will be the right answer. So without getting into graphical method or simplex method, you can solve this problem in this way. Why shouldn't we take all the points into z is equal to 30x minus 18y directly? Just substitute 2, 0 in this minimization function. 30 into 2 will give you 60. Comparing 60 and 120, you have 60 to be the minimum value. So definitely you have to pick B as the solution. But does B satisfy both the constraint? No. Instead of finding Z value and then checking whether the constraints are fine or not, you can first check whether the points are satisfying both the constraints. Those points alone you can substitute in objective function. Next question. Which of the following statements are true about the sets? 0 belongs to empty set. Empty set representation is phi symbol. A is false because the empty set contains no element. They are asking which are true. Whichever options involve A can be ruled out, and from here itself you can find option 4, C and E only will be the right answer. Let's check for the other options. Empty set belongs to set with element 0. This is also false. The set 0 contains a single element which is 0. But here they say it's an empty set. It has no element and it has one element, that is 0. So it is false. What about C? Empty set belongs to set with empty set. This is true. The empty set is an element of the set. So inside this we have one element in the RHS. What is that element? It is phi. What is phi? It is empty set. Is it the same as LHS? Yes. This particular set with an empty set is a set that contains one element, which is the empty set itself. So they are equating this empty set belongs to this particular set, which is perfectly true. So C is true. What about D? Actually, both the LHS and RHS are equal here. We cannot say they belong to. It is false. Set with empty set is not an element of set with empty set. Instead, it is equal. This is a set and inside that you have empty set. This is what is present in both LHS and RHS. It can be denoted by equal to symbol and not belong to. When do we use actually belong to? Belong to means we can say this element belongs to a particular set, or we can say this element is member of a particular set. What about E? This symbol is actually proper subset. Say for example, if we have 1, 2 here and we have only 1, this will be the proper subset. This element can be one of the elements in RHS, but it should not be equal to RHS. Now just take E. This set is a proper subset of this particular set. The set contains only one element, which is the empty set. This is with respect to LHS. What about RHS? The set empty set, comma set with empty set contains two elements. This is one element, this is one element. The empty set and the set with empty set. So this is definitely a proper subset. Next question. Match the list 1 with list 2. Match the logical equivalence propositions. There is a series in this channel, CS Connect series. Under that, mathematical logic playlist is there. If you go to propositional equivalences video, you can watch that video for elaborate explanation of propositional equivalences. In list 1, let's go for A. We have P implies Q. We know P implies Q is equivalent to negation of P or Q. This is one of the propositional equivalence law that we know. So based on that, we are mapping A to 2. A2 is available in 2 of the options. Next, we have one more law with regard to by implication operation. P by implies Q will be equivalent to P and Q or negation of P and negation of Q. This is also listed in one of the laws in prepositional equivalences. So C will be mapping to 1. So we have two options matching here. C is wrong here. So we will go with option 3 as the right answer. So let's start with C first. So let's take P by implies Q. What is P by implication Q? It is P implies Q and Q implies P. This is the basic law that we know. What is P implies Q? It is negation of P or Q. And what is Q implies P? It is negation of Q or P. Now we'll just try to expand this. This is negation of P, negation of Q with conjunction. So negation of P and negation of Q. Then we have disjunction here. We'll place it outside. Then we'll go with Q and negation of Q. Then we'll go with disjunction again. Then we have negation of P with P. So negation of P and P. Again we will go with disjunction. Then we have Q and P. So this will be Q and P. What is Q and negation of Q? It is actually false. What is P and negation of P? It is actually false. When you have disjunction with false, what happens? If you have P disjunction false, this will be equal to P. So taking that into account, we can forget about these two terms, and finally we will have negation of P and negation of Q, or Q and P can be written as P and Q. Now rearrange this P and Q or negation of P and negation of Q. Did we get list 2 first option here? Yes. Now let's get into B. We have negation here. P or negation of P and Q. We will apply the negation inside first. This will become negation of P. Negation of disjunction will become conjunction. Then we will apply the negation to the complete expression here. This will be negation of negation P and Q. Now negation of P and conjunction will stay as it is. Apply here negation of negation P. Negation of conjunction will give you disjunction. Then we have negation of Q. So this can be written as negation of P and P or negation of Q. So this can be negation of P and P. Take the disjunction outside. Then we go for negation of P and negation of Q. What is negation of P and P? This will be false. False disjunction, some preposition will be the preposition itself. So this will be negation of P and negation of Q. If you take the negation outside, this will be P and Q and this will turn to disjunction. This is available in 3. So B will be mapping to 3 here. If you have found the solution, what you can do is you can start with 3. This will be negation of P or Q. This can be taken as negation of P and negation of Q. So this particular expression and this particular expression are same. Let's take this to be B1 and this to be B2. B1 and B2 are same. From here also you can say B will be mapping to 3. So here it is C1. Now we will move to D expression. Negation of P by implies Q. We will use the same law here. Just have negation. Go with P implies Q and Q implies P. Apply the negation inside. This is negation of P implies Q. This negation will change conjunction to disjunction. Then negation of Q implies P. P implies Q can be negation of P or Q. Disjunction, negation of Q or P. Now we will have negation of negation P. Negation of disjunction will be conjunction and this will be negation of Q. This is one expression. Let's have disjunction as it is. Now we will have negation of negation Q and negation of P. What will this give you ultimately? Negation of negation P will be P and negation of Q, or we will have Q negation of P. This will be P disjunction Q. We will have AND here. Then P disjunction negation of P. We will again have AND here. We have Q disjunction negation of Q or negation of Q disjunction Q. Then we have AND. We have negation of Q disjunction negation of P. So what is P or not P? This will give you true. Q or not Q will give you true. P and true will give you P. Taking this into consideration, we are not worried about this true in conjunction. Similar to false in disjunction, we will go with P or Q and negation of Q or negation of P. This can be otherwise written as P or Q and negation of P or negation of Q. So this can be taken as D1. Now the left out option is actually 4. Negation of P by implies Q. Basically we will write P implies Q and we have Q implies P. This is for P by implies Q. Now wherever you have P, just negate it. Here is a negation, here is a negation. What is negation of P implies Q? It is negation of negation P or Q, and we have negation of Q or negation of P. What is negation of negation P? It is P or Q and negation of Q or negation of P. Just rearrange it, P or Q and negation of P or negation of Q. This is D2. Are they equal? Yes, they are equal. So from this we can say D will be mapping to 4. So from this we can conclude option 3 will be the right answer. Just for examination point of view, work only with A and C to find the answer. To make it very short, just work with C alone. So if you find C is 1, definitely without checking A, B and D, you can conclude the answer. With this we are completing Unit 1 solutions. Let's solve Unit 2 Computer System Architecture questions. Match the list 1 with list 2. We are given Boolean algebra law in list 1 and the axioms in list 2. Let's start with absorption law. Absorption law, A will be mapping to 4. A plus A into B is equal to A. A4 is available in 2 of the options. We can rule out the other 2. What about bounded law? If you are new to this term, you can directly move to distributive law to find the answer. Distributive law, D will be mapping to 3. A into B plus C is equal to A into B plus A into C. D3 is available only in one option, so we can even rule out this one. So based on A and D's answer, we can conclude option number 1 to be the right answer. What about identity law? C will be mapping to 2. A plus 0 is equal to A. What about bounded law then? A plus 1 is equal to 1. B will be mapping to 1. So we have A4, B1, C2 and D3 as the right answer. Next question, consider a pipeline unit for fixed point multiplication of 8-bit integers. Arrange the following stages in a correct sequence. Let's take that we don't have any idea about pipeline unit for fixed point multiplication. Without any idea, how are we going to solve this question? Let's read the stages. Stage A consists of 2 CSAs and it merges 4 numbers from previous stage. Based on this particular clue, previous stage, we know this particular sequence will not start from A. So we can rule out option 4. What about stage B? Is a CPA which adds up the 2 numbers. From here we can understand that it is going to be a continuation of some stage. The option starting with B will also be ruled out. What about C? Is made up to 2 level of 4 CSAs. Again, this is a continuation statement. So we can even rule out option 1 that is starting with C. Now the only option that is left is option 2. Stage D generates 8 partial products. This is the only stage that feels like the beginning of the sequence. And we have only one option that is starting with D. So just based on this you can mark option 2 to be the right answer. You can use this particular approach when you don't have any idea about the topic from which the question is asked. Now we'll get into the learning. Let's consider an example, the multiplication of two 8-bit integers a and b. So they have given 8-bit integers multiplication. So we are picking two 8-bit integers here. A into b is equal to p, where p is the 16-bit product. This fixed point multiplication can be written as the summation of 8 partial products as shown below. P is equal to A into B can be expressed in 8 partial products along with summation. So this will be P0 plus P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus P7. So there are 8 partial products where this symbol is arithmetic multiply and this symbol is add operation respectively they have given. Now let's see about the stages. This is the exact diagram that we can find in Advanced Computer Architecture book. So this is A and this is B. We have two 8-bit integers here. The first stage generates all 8 partial products ranging from 8 bits to 15 bits simultaneously. So here it is the number of bits. So again we have 8, 9, 10, 11, 12, 13, 14, 15 bits. This is what they have given as ranging from 8 bit to 15 bit. This is S1 stage and here we can equate it to generates 8 partial products which is D. After that we have the second stage. The second stage S2 is made up of two levels of 4 CSAs and it essentially merges 8 numbers into 4 numbers. So this is level 1 and this is level 2. How many CSAs are there? There are 4 CSAs. 1, 2, 3, 4. This is stage 2. Which stage is having the same statement here? Is made up to 2 level of 4 CSAs. This is the clue that we can get from this particular statement. So the next stage will be stage C here. What about the third stage? S3 consists of 2 CSAs and it merges 4 numbers from S1 into 2 16-bit numbers. So how many CSAs are present? 2 CSAs, that's what is given here, and they say it merges 4 numbers from S1. S1 is nothing but the previous stage. So here this can be equated to consists of 2 CSAs and it merges 4 numbers from previous stage. This previous stage is what is denoted by S1 in this particular statement. So the next stage will be A. What about S4 stage? The final stage is a CPA which adds up the last 2 numbers to produce the final product P. This is a CPA which adds up the 2 numbers is what they have given in stage B. This will be the final stage. DCAB is available in option number 2. So we go with option number 2 as the right answer. Now we have come across 2 terms, CSA which is carry save adder and CPA which is carry propagate adder. What are they? High speed addition requires either the use of a carry propagation adder CPA which adds 2 numbers and produces an arithmetic sum, or the use of a carry save adder CSA to add 3 input numbers and produce 1 sum output and a carry output. So in stage 2 and stage 3 we are going with CSA and in the final stage we are going with CPA. If you get to learn about CPA and CSA, they will tell you how this bit by bit addition is performed and where the carry goes everything. So I am not including those details here, but if you want to extend your learning about CSA and CPA, you can refer to Advanced Computer Architecture books. Next question. Arrange the following in the increasing order with respect to access time. So let's see a diagram now. We have 5 levels here. Registers in CPU, cache which is denoted by SRAMs, static memory. Then we have main memory, the dynamic RAM, the disk storage which includes solid state and magnetic drives. Regarding the last level, we have backup storage which includes magnetic tapes and optical disks. They have given increase in cost per bit from bottom to top in this side, but here it is given as increase in capacity and access time from top to bottom. So if something is going to be accessed in 0.1 second here, this will take around 5 to 10 seconds here. So you have to arrange from top to bottom to get the increasing order with respect to access time. Increasing means from small count to large count. Ascending order we can take. So we will arrange this. First we have registers in CPU. It is available in option E here. What about SRAM? It is D. What about DRAM? It is C. What about disk storage? Here we are referring to solid state drive. So this will be A. What about optical disk? It is B. EDCAB is available in option number 4. Option 4 will be the right answer. Regarding these 4 options that is given for this question, once you find registers are going to take the least access time, you can answer this question without worrying about SRAM and DRAM. Next question. Which table for a dynamic pipeline become more interesting when a non-linear pattern is followed? In previous year questions, we have solved about pipelining and we have non-pipeline too. What is this dynamic pipelining? This is actually called as non-linear pipelining. This can be reconfigured to perform variable functions at different times. The traditional linear pipelines are static pipelines because they are used to perform fixed functions. You must have seen this diagram even in the solution videos. There will be 5-stage pipeline. All the stage will be going in a linear way for every instruction like fetch, execute, etc. So that is linear pipeline and they are called static pipelines. When there is no linearity, we can term it as non-linear pipelining or dynamic pipelining. Actually, dynamic pipelining is the right word. Some authors use non-linear pipelining, so I have mentioned even that term here. A dynamic pipeline allows feed forward and feedback connections in addition to the streamline connections. In linear pipelining, the stage will be moving on forward, but here you even have feedback connections. So you can see this diagram. This is a 3-stage pipeline. So this is moving forward. At the same time, it is just moving backward also. Out of these 4 options, reservation table is associated with dynamic pipelining. The reservation table for a static linear pipeline is trivial in the sense that data flow follows a linear streamline. Trivial in the sense it is of not much importance. Why they say it is not important? Because when you take linearity, it is going to go in the same flow. There is no alteration. So there is no use of looking for the reservation table. But when there is non-linear approach, reservation table will have significant role there. The reservation table for a dynamic pipeline becomes more interesting because a non-linear pattern is followed. Given a pipeline configuration, multiple reservation tables can be generated for the evaluation of different functions. There is a possibility to have more than one reservation table in dynamic pipelining. So you can see this diagram here. One reservation table for a particular function x and the other reservation table for another function y. From this we can conclude option number 1 to be the right answer. Reservation table becomes more interesting because a non-linear pattern is followed. The exact statement is actually asked in the question. Next question, which are often needed to evaluate the cache performance? Let's see about the options first. What is hit ratio? The proportion of memory accesses that are successfully served by the cache memory. What about latency? It measures the time it takes to retrieve data from the cache. What about cache traces? This is a term that is helpful in analyzing and understanding memory access patterns. And what about transfer rate? Evaluates the speed at which data is transferred to and from the cache. In general, if you take about hit ratio, this provides a clear indication of how effectively the cache is serving memory accesses. A high hit ratio means the cache is frequently used, reducing the need to access slower main memory. So keeping this particular point in mind and the previous knowledge that we have about hit ratio, we can go with option number 1, hit ratio, as the right answer. But before providing hit ratio in the final answer key, the third option, cache traces, was given as the key in the provisional answer key. Where did this confusion actually occur? Some of the questions for this particular session is actually taken from Advanced Computer Architecture book written by K. Wang. In that book, we have certain statements. Due to the difference between page allocation in main memory and block allocation in the cache hit ratio and memory page hit ratio are affected by replacement policies differently. Cache traces are often needed to evaluate the cache performance. This was the statement that is actually asked in the question. This is the reason behind provisional answer key cache traces. But what is actually cache trace? They have given like this content will be discussed in a later chapter. But when you get inside the later chapter, you cannot find the term cache traces. What they have talked is the performance of a cache design concerns two related aspects, the cycle count and hit ratio. The cycle count refers to the number of basic mission cycles needed for cache access, update and coherence control. And the next one, the hit ratio, determines how effectively the cache can reduce the overall memory access time. So they have given this content will be discussed later, and in the later part of the book, these two terms were mentioned. So the right answer will be hit ratio and not cache traces. So I am just giving you clarification of why cache traces cannot be the answer. Next question. Which of the following is the simplified form of the given function? F of a comma b comma c is equal to summation of min terms 0 comma 1 comma 3 comma 7. So in 4 positions we have to place 1. Let's take the K map here. So we can take this to be A and this to be BC. This will be A dash, this will be A. Here it is B dash, C dash, B dash, C, B, C, B, C dash. What are the places where we should place 1? 0, 1, 3, 7. Now we have to do grouping. So we can group these two ones and these two ones. So what is common with respect to these two cells? A dash is common and we can take B dash here. So A dash B dash will be coming for this particular grouping. Now we'll get into this grouping. What is common here? We have BC common here. So the simplified format will be A dash B dash plus BC. This is available in option number 3. Option 3 will be the right answer. Next question. Which of the following is the complement of the Boolean function? We are going to apply complement to the complete function here. Before that, we will understand what is a complement. The complement of a Boolean function is obtained by flipping all the values of the function from 1 to 0 and from 0 to 1. Now let's find the complement of this particular function. Let's take f is equal to a dash b cd dash a dash b plus cd dash. Now you have a repetition of term here. And similarly repetition of the other term. When you are going to have 1 plus 1, that will give you 1. When you are going to have 0 plus 0, that will give you 0. So we can simplify this and make it as f is equal to a dash b plus cd dash. Now we will find the complement of this particular Boolean function. It is denoted by f dash. We have to apply complement to the whole expression. A dash b plus cd dash the whole dash, or the whole complement. We will take a dash b separately and apply this complement. Then we will apply for cd dash the whole complement. Now this particular complement of addition will become multiplication. So this is dot. Now apply the complement to individual variables here. So this will be a double dash. Instead of this dot we can go with plus, and this will be b dash after applying complement. We will have the braces here. This will be into c dash plus d double dash. So how can we write a double dash? A complement to the complement will be a only. So this will be a plus b dash into c dash plus d. This particular expression is available in option number 3. Option number 3 will be the right answer. Next question, correct the order of instruction cycle. So let's see the sequence here. In the basic computer, each instruction cycle consists of the following phases. Fetch an instruction from memory. So we can equate this to fetch the information in B. So this will be B. Decode the instruction. It is given in D. Read the effective address from memory if the instruction has an indirect address. So we can go with A, read the effective address. Execute the instruction will be C. B, D, A, C is available in option number 2. Option 2 will be the right answer. Next question, which of the following is the correct sequence with regard to service routine? So this question was earlier asked in one of the question paper. So let's see the sequence. The service routine must have instructions to perform the following tasks. Save contents of processor registers. This is available in A. Check which flag is set. This is D. Service the device whose flag is set. This will be C. Restore contents of processor registers. This will be E. Turn the interrupt facility on will be B. Return to the running program is the final task here. A, D, C, E, B. It is available in option number 4. Option 4 will be the right answer. Next question. Which of the following are not data manipulation instructions? Data manipulation instructions perform operations on data and provide the computational capabilities for the computer. The data manipulation instructions are usually divided into 3 basic types: arithmetic instructions, logical and bit manipulation instructions, and shift instructions. So let's see about all these instructions separately. In arithmetic, we have increment, decrement, add, subtract, multiply, divide, add with carry, subtract with borrow, negate, that is 2's complement. What about logical and bit manipulation? Clear, complement, and or exclusive or, clear carry, set carry, complement carry, enable interrupt, disable interrupt. What about shift instruction? Logical shift right, logical shift left, arithmetic shift right, arithmetic shift left, rotate right, rotate left, rotate right through carry, rotate left through carry. Any instructions that fall under these 3 categories will alone be taken as data manipulation instructions. Do we have call anywhere? No. Do we have loud anywhere? No. Do we have and? Yes, it is available in logical. So this one is logical. What about increment? It is available in arithmetic. So this is arithmetic. What about shift? Though they have not mentioned what kind of shift it is, they have given it as an instruction. So shift is definitely an instruction because we have arithmetic, logical and shift instructions. So we can take the third point as it is. So this is shift. So C, D, E are data manipulation instructions. From here we can understand A and B are not data manipulation instructions. So we can go with option number 2, A and B only as the right answer. Now let's see about program control instructions. Here we have branch, jump, skip, call, return, compare by subtraction, test by ANDing. So here we have call. This call is nothing but program control instruction. Next question. Which of the following do not represent memory reference instruction? We have basic computer instruction formats. There are 3 kinds actually: memory reference instruction, register reference instruction, input-output instruction. Here this question is with respect to memory reference instruction. So what is this mode and opcode? Mode bit indicates the addressing mode. If mode is equal to 0, it means it is direct addressing. If mode is equal to 1, this can indicate indirect addressing or other modes. Opcode specifies the operation to be performed. So when you have a fixed mode of 0 and the opcode to be 111, all these instructions fall under register reference instruction. When you have I is equal to 1, that is the mode is equal to 1, which is indirect addressing, and the opcode to be 111, they fall under input-output instruction. You have mode 0 opcode 111, mode 1 opcode is equal to 111 in option B and C. So based on this we can mark option number 1 to be the right answer. But the official answer is given as B and D. Just check with the memory reference instruction that is given here. We have 1, 2, 3, 4, 5, 6, 7 instructions ranging from 0 to 6. So you can see the opcode is equal to 000 through 110. So the values can be 000, 001, 010, 011, then 100, 101, 110. Once you have opcode is equal to 111, they don't come under memory reference instruction. Opcode is equal to 111 is often used for non-memory reference that do not involve memory access is what we can understand from this. They have asked which do not represent, that's why we are picking B and C, which means A, D, E are a part of memory reference instructions. If you take opcode in A, it is 010 which is available here, 110 it is available here, 001 is available here. This I mode can be either 0 or 1. That's why they have mentioned it as I directly. They have not given a value as 0 or 1. That happened in register reference and input output. Next question, match the list 1 with list 2. Let's start with A. We have a binary number 100 110011. Base 2 means it is in binary form. And in list 2 we have a number in hexadecimal. To convert binary to hexadecimal, you have to group the digits by 4. These 4 should be grouped together. These 4 should be grouped together. You can even prepend zeros here and bring this to 4 terms. What is 0011? Just go for 8421 code. 0011 will give you 3. So this is 3. 0011 is again 3. What about 1? When you have 000 and 1, this is equal to 1. So this will be 1. You have 133 to the base 16 because you are converting it to hexadecimal. There is a series in this channel, CS Connect series. Here you have a playlist called Number Systems. In that playlist you have base conversions video. So in that video you can learn about the conversions between decimal, binary, octal and hexadecimal numbers. A will be mapping to 4. A4 is available in 3 of the options. So we can rule out 4. What about complements? Actually, what is the purpose of introducing the concept of complement is, it is to represent negative number. So we can map B to 3. A4, B3 is available only in one option. We can rule out the other 2 and we can mark option number 2 to be the right answer. What about C parity bits? When you take digital logic content, when they introduce parity bit, it is for error detection purpose. So parity bit is about error detection code. C is mapping to 1. What about variable length instruction? This is actually associated with CISC instruction set. D is mapping to 2. With this we are completing Unit 2 solutions. Let's solve Unit 3 Programming Languages and Computer Graphics questions. Which of the following statement is not true? So we will go statement by statement. First one, a data member of a class can be declared as static and is normally used to maintain values common to the entire class. This is actually true. Declaring a data member of a class as static means the member belongs to the class itself rather than to any specific instance of the class. This way, the static member is shared among all instances by making it ideal for maintaining values that should be common to the entire class. So we will mark this to be true. The next statement, a friend function can be invoked like a normal function without the help of any object. This is also true. A friend function in C++ can be invoked like a normal function. Since it is not a member of the class, it is called just like any other non-member function. It can access the private and protected members of the class. It is a friend too. So this one is also true. What about the next one? The scope resolution operator can be overloaded like normal operators. This is actually false. This cannot be overloaded. So let's see about the fourth statement also. Multiple inheritance may lead to duplication of inherited members from a grandparent base class. This may be avoided by making the common base class a virtual base class. This is also true. The duplication of inherited members issue is actually known as diamond problem. To avoid this issue, we can make the common base class a virtual base class. So this is true. By doing so, the derived classes will inherit a single instance of the base class, preventing duplication and ensuring a more manageable inheritance structure. Option number 3 will be the right answer. This is the only false statement. Next question. Which of the following is not true about global variables? So we have to take every statement in the context of global variables only. So what are global variables? They are available throughout the program. They are not local to any specific function. The values of the global variables which are sent to the called function may be changed inadvertently by the called function. Inadvertently means not doing it intentionally, but they are saying it can be changed by the called function. This is true. If a global variable is passed to a function, since they have global scope, they can be accessed and modified from any function within the same program. So when they are passed to a function, the values can be changed by the called function. We can mark it to be true. The next one. Functions are supposed to be independent and isolated modules. This character is lost if they use global variables. This is also true. We know functions are independent and isolated modules. When they rely on or modify global variables, this will make the code harder to understand, maintain and debug. So it's always a good practice to pass necessary data through function parameters and return values, preserving the modularity and independence of functions. So let's take a function and we have a set of parameters here. Instead of using global variables which are available all through the program, when you want to pass some specific value, you can use this parameter list. Similarly, when you want to get some value out of the function, you can use return values. Just based on function parameters and return values, we can pass necessary data without relying on global variables, because when they use global variables, they will lose the character of being independent and isolated module. This statement is also true. What about the next statement? It is not immediately apparent to the reader which values are being sent to the called function. When you take global variables that are used in functions, will you be able to understand where the variable is from when you see the function code? No, it will not be so clear to the reader is what they say. Apparent means it is not immediately visible. That's what they have given as it is not immediately apparent to the reader. When functions rely on global variables, it becomes less clear to the reader which values are being used by the called function. When you are sending it through parameters, you will know these values are sent. But when you are using global variables, it will not be so clear is what they say. This makes the code harder to understand and maintain. Ideally, function should be designed to take all necessary inputs as parameters and return any results, making their behavior explicit and predictable. So the same thing they are repeating. Use parameters and return values. So this statement is also true. From here we know option 4 will be the answer. So let's see the final statement. A function that uses global variables does not suffer from reusability. This is false. Then what will be the right answer? The function that uses global variables often suffers from reduced reusability. This part is wrong. it actually suffers. This is because the function's behavior is tied to the specific global variable it uses, making it less adaptable to different contexts. Reusable functions should be self-contained with all necessary data passed through parameters. This approach makes the function more flexible and easier to reuse in various parts of a program or even in different programs. When you are going to use the same function in different parts of a program or in different programs, if they are going to rely on the data that is passed through parameters, it's fine. But when they are going to rely on global variables, it will become less adaptable to different context is what they say. So the only false statement they have asked about not true. It will be option 4. Option number 4 will be the right answer. Next question. Consider the following statements. Int x is equal to 10, y is equal to 15. They have initialized the values of x and y. What is this particular expression? This is actually ternary conditional statement, we can say. The format will be condition true or false. It means when the condition is evaluated to be true, this particular expression will be executed. When the condition is evaluated to be false, this condition will be executed. What is the condition here before the question mark? They have given x is equal to y. In case if they have given x is equal to y, here this is 10 and this is 15, so we know it is not equal. But here this operator is not given. They have given assignment operator. Assignment operator means you have to assign the value of y to x. What is y? It is 15. It has to be assigned to x is what this particular expression is telling you. Now after applying y to x, what will be the new x value? It will be 15. So this will be the value of x now. Has the value of y changed? No. Y is equal to 15 is staying as it is. It is changing the value of x alone. Now when you have a condition of a particular variable greater than 0, that will be evaluated to true. Already in one of the previous year question paper we have seen this. In an expression, when a particular value is greater than 0, it will be evaluated as true. When it is equal to 0, it will be evaluated as false. So based on this particular condition, we have the value of x is equal to 15. So there is some value that is greater than 0, which will make this particular condition to be true. After having true here, which expression will be executed? Y plus x will be executed. What is y? We have 15. What is x? We have 15 as the new value. 15 plus 15 will give a value of 30. Where is this particular expression assigned? It is assigned to the variable x. Now what did this particular expression evaluate to? It evaluated to 30. So now x is equal to the ternary expression. The ternary expression's value is 30. So x will be having the value of 30. What will be the value of x? After executing these statements, it will be 30. Option number 4, 30 will be the right answer. Let me remind you once again, x is equal to y will evaluate to false because x has the value of 10, y has the value of 15, both are not equal. But when they use assignment operation, x is equal to y, this will assign y's value 15 to x. So this condition will be evaluated to true. Next question, the light given off by the phosphor during exposure to the electron beam is known as, it is actually known as fluorescence. Fluorescence occurs when a material absorbs light or other electromagnetic radiation and then re-emits it almost instantaneously. Option number 1, fluorescence will be the right answer. If you take persistence, it is actually staying for a long time. So that term is not relevant to this particular statement. If you take retracing, at the end of each scan line, the electron beam returns to the left side screen to begin displaying the next scan line. That is retracing. This way we will be doing tracing. So retracing means starting again from the left side. It is also not relevant to the given question here. Next question, arrange the 2D viewing transformation pipeline. So let's see the two-dimensional viewing transformation pipeline. We are starting with modeling coordinates, that is MC. Construct world coordinates C using modeling coordinates transformation. We are starting with C. We see that no option is actually starting with C. That's why this question is dropped in the official answer key. From here we are getting world coordinate, that is WC. Next step is convert world coordinates to viewing coordinates, that is available in A statement. We have VC, which is viewing coordinates. Transform viewing coordinates to normalized coordinates, that is NC. We will go with B here. Map viewing coordinates to normalized viewing coordinates using window viewpoint specification. So when you take a scene, that is the world coordinate, we can assume. From there we are moving to a particular viewing coordinate, that is for a particular viewpoint. Based on the window viewpoint specification, we are mapping it to normalized viewing coordinates. We will see the next step. Map the normalized coordinates to device coordinates. This will be D. When you have converted to NC, this particular viewpoint has to be converted to a specific device. That can be a mobile, that can be a tab, that can be a desktop. It can be converted to any device is what they say. The pipeline order will be CABD. Due to a printing mistake, it has mentioned as DABD. Actually, this should have been C. CABD will be the right sequence for this particular question. Next question. Consider the following conditional statements if m is equal to 20 minus 10 or n greater than 10. The order of execution of the following operations is. So first we have to know the precedence of these operations. 20 minus 10 is actually subtraction. So we have to start with this particular operation. Where is minus available? It is available in B. After subtraction we have relational operator, greater than and less than. We have greater than symbol here. It is available in D. N greater than 10. The next order will be equal to. For relational equality they have given. So equal to is available next. It is A. This will be M is equal to. Then we have logical OR, which is C. This one. So we have B, D, A, C. Option number 3 will be the right answer. Now we will just try to evaluate this. What is 20 minus 10? This is 10. Where should I place this 10? Here. Now we have n greater than 10. We will have only one of the two options. It should either be evaluated to true or false. Similarly, we are checking if m's value is equal to 10. Here also we will have a possibility of true or false. Now just check the if condition. This particular part is evaluated to true or false. We have OR operation. This particular expression is evaluated to true or false. When both the sides are going to be false, you will have false ultimately. When you have true on one side like this or true on both the sides, all these three will be evaluated to true. Next question. Match the list 1 with list 2. List 1 has functions. List 2 has uses of functions. What functions are they? They are actually file handling functions. So let's see about them one by one. fseek function moves file pointer position to given location. Which statement in list 2 is having a similar meaning? Sets the position to a desired point in the file. Desired point can be equated to given location. A will be mapping to 3. A3 is available in 2 places. We will rule out the other 2. Then we have ftell. Ftell function is used to get current position of the file pointer. We have the statement gives the current position in the file. B will be mapping to 1. B1 is also available in both the options. What about C? FEOF. This function finds end of file. Whenever we have file handling programs, usually we will use the function FEOF to check whether we have reached the end of file. This can be equated to used to test for an end of file condition. C will be mapping to 4. C4 is available here and not here. So we can rule out even 3. What about D? Rewind function is used to move file pointer position to the beginning of the file. Sets the position to the beginning of the file is the actual meaning here. D will be mapping to 2. D2 is available here. A3, B1, C4, D2. Option number 2 will be the right answer. Even if you have no idea about FC, FTL and rewind, if you are sure about FEOF function, because we might have used this in programming, if you are sure about this C will be mapping to 4 directly. C4 is available only in one option. You can mark the answer of this particular question even without having ideas on A, B and D. Next question. The major adverse side effects of scan conversion are. What is scan conversion? The task of digitizing a picture definition given in an application program into a set of pixel values for storage in the frame buffer is called scan conversion. So just take a normal scanning process. We'll just have a paper with something written there. So when you put it in the scan part, that will be given in the form of a soft copy. It will be converted as an image. So similarly, you can take it to be a digitizing process given in an application program to a set of pixel values for storage in the frame buffer. So here we can understand we are converting from one form to another. So there will be definitely some kinds of problem involved during this conversion. So they are asking for the major adverse side effects. The side effects of scan conversion has an alternate name called aliasing effects. What are the different aliasing effects for scan conversion? Staircase appearance. You can take, it will be in the form of a staircase appearance in certain pictures. This occurs when diagonal lines appear jagged or stepped rather than smooth due to the discrete nature of pixel representation. Instead of going this way, it will be in this way. This will give a representation of a staircase. So this is staircase appearance. This is definitely an aliasing effect. A is into the solution. The next one is unequal brightness of slanted lines. This happens when the brightness of slanted lines varies, causing some parts to appear brighter or darker than others. This particular statement is equating to B. Sometimes we will not have equal brightness on the picture. Some area will be dark, some area will be lighter. So that problem is actually given as unequal brightness. Next side effect is picket fence problem. This is a type of aliasing effect where evenly spaced lines appear uneven due to the snapping of endpoints to pixel coordinates. You can take evenly spaced lines, but they do not appear even is what they say. They appear uneven. So this particular problem is picket fence problem. It is available in C. So we have 3 side effects here. A, B and C. They are available in option number 2. Option 2 will be the right answer. What about D and E? Rasterization is the process of converting vector graphics into raster images. We are converting to pixels, which can introduce artifacts and reduce image quality. Artifacts in the sense some kinds of problems you can take and reduce image quality. Actually, scan conversion is a part of raster scan systems. So definitely rasterization is the process that is associated with this particular topic. So it cannot be the side effect. We can rule out D. What about pre-filtering and post-filtering? These are techniques used to reduce aliasing and improve image quality. But they can also introduce blurring or other artifacts if not done correctly. What is blurring actually? Blurred image means the image is not clear. You cannot see what is in the image very clearly. So that is blurring. They are saying pre-filtering and post-filtering as techniques to reduce these side effects that are mentioned in A, B and C. If we use pre-filtering and post-filtering techniques, they can improve image quality. But again, we have a disadvantage there. It may introduce blurring effect or some other effects if they are not done correctly is what they say. So this can also be not a side effect, but this is actually a technique solution to reduce the side effect. Next question. The characteristics of modern programming are. Modern programming in the sense what we are actually following now. The modern approach to programming you can take. They have given 4 statements. Each module should do only one thing. Communication between modules is allowed only by a calling module. Communication can take place directly between modules that do not have calling-called relationship. All modules are designed as single entry, single exit systems using control structure. We have to choose the correct answer. So whichever characteristics apply for modern programming, that alone we have to pick. Now we will see about the characteristics. Each module should do only one thing is a characteristic of modern programming. A is in the solution. Since A is in the solution, we can rule out option 4. This aligns with the principle of modularity and separation of concerns, ensuring that each module is focused on a single responsibility. It means every module is associated with one particular task we can take. Say for example, let's take this to be a module. So this is designed for or coded for only one purpose. Let's go for the D statement. All modules are designed as single entry, single exit systems using control structure. This is also a characteristic feature then. How do we say that? Say for example, if you want to get a particular task done, you have to get into the module. What point is this? This is actually single entry point we can say. Once you have completed the task, you have to get out of the module. It might be in the form of a function that returns a value or a function that changes something, prints something and then coming out. You can take any function related example. So once you get a value or once you get the task done, you are coming out of it. So this is single exit system we can say. So D is also included in the solution. 1 will be ruled out now. Next we will see about communication between modules. Actually let's take 2 modules A and B. This is going to be independent and this is going to be independent. This is for some task T1, this is for some task T2. They don't have calling or called relationship. When they don't have any relationship between them, how can the communication happen for A and B? That can be done by a calling module here. We can pick the term from B statement. Communication between modules is allowed only by a calling module. This module will interact with A and this module will interact with B. When they have no relationship, this communication will happen only by a calling module is what B point says. This is actually right for modern programming. This emphasizes controlled communication, which is a key aspect of modular programming and helps in maintaining clear interfaces between modules. It ensures that communication follows a well-defined path, reducing complexity and potential errors. So this will be point B. We will go with option number 2. A, B and D only as the right answer. We can even rule out option 3 because C is not right. So what is wrong with C? This is generally discouraged in modern programming as it can lead to tightly coupled systems, making the code harder to maintain, understand and debug. They have given modern programming, but all the content is with respect to modules. So what you can understand is modern programming is encouraging modularity. With this we are completing Unit 3 solutions. Let's solve Unit 4 Database Management System questions. Which of the following command can be used to modify data in an SQL table? When you take insert command, what we actually do is we insert some data inside the table. So you are doing something to the data. This can be considered for the solution. What about delete? You are actually removing the existing data. Again this is equal to modification of data. So delete is also there. What about update? Update is you are rewriting some value in the record. You can either update a particular field of a specific record or without any condition you can update more than a record. So definitely in update we have modification of data. What about select? In select you are not going to feed any data, you are not going to remove any data, you are not going to update any data. No work is going to happen with respect to data modification there. but you are going to just retrieve data. Retrieve means whatever is present in the table, that will be given as output. You are not going to do anything in the table, but in insert you are adding one row, in update you are modifying one row, in delete you are deleting that row with respect to a single record I am telling you. So in select we don't do any data modification, we just read the values. So we are going with A, B and C alone as the answer. Option 4 will be the right answer. Next question. In concurrency control, phantom problem may occur when? Actually, we have come across this phantom problem in certain previous year question papers. A situation known as the phantom problem can occur when a new record that is being inserted by some transaction satisfies a condition that a set of records accessed by another transaction must satisfy. During what operation does this situation occur? When a new record that is being inserted. Just look at the options. Records are inserted, records are deleted, records are modified, records are indexed. Phantom problem may occur when records are inserted. Option number 1 will be the right answer. So let's understand about this phantom problem. A transaction T1 may read a set of rows from a table, perhaps based on some condition specified in the where clause. Just take for an example those who are preparing for UGC NET Computer Science. We are going to retrieve a set of rows. Say for example we are retrieving 5 rows and this is done by transaction 1. Suppose that a transaction T2 inserts a new row R that also satisfies the where clause condition used in T1 into the table used by T1. Say for example this is going to be table 1. In this table another transaction T2 is going to insert one record. Say for example we are going to collect the details of students who are learning for UGC NET exam. So in one particular column we are just going to get the specialization alone. So maths people will enter maths, CS people will enter CS, then English people will enter English. It goes on. So now this T1 is retrieving records who fall under the category CS. There are 5 rows taken totally. Now T2 is inserting one record again for computer science. The record R is called a phantom record because it was not there when T1 starts, but it is there when T1 ends. This is starting in 0.1, this is happening in 0.2 and T1 is ending at 0.3. When it started that particular process, this record was not there, but when it ended up the process, the record is present. So this record is what they call as phantom record. T1 may or may not see the phantom, a row that previously did not exist. If the equivalent serial order is T1 followed by T2, then the record R should not be seen. So once it completes T1 and then it goes to T2, definitely this record will not be seen by T1. But if T2 followed by T1, then phantom record should be in the result given to T1. In case if T2 is going to be executed first and then T1 is executed, then definitely this phantom record R will be present. If the system cannot ensure the correct behavior, then it does not deal with the phantom record problem. Next question. Which of the following table contains the primary information in the data warehouse? In a data warehouse, the table that contains the primary information is the fact table. We'll go with option number 2 as the right answer. Fact tables store quantitative data for analysis such as measurements, metrics, or facts about a business process. They are typically at the center of a star or snowflake schema. These are the terms that are related to data warehousing. If you want to know more about it, you can always explore. And they are related to dimension tables. What are dimension tables then? Dimension table stores descriptive attributes or dimensions related to the facts such as time, location or product details. So here they say fact tables are related to dimension because this dimension table is actually holding the description of those attributes that are related to the fact table. What about lookup table? They are used to map or reference data, often containing a subset of information for quick access and validation purposes. So from this we can rule out dimension table and lookup table. What about primary table? This is actually not a standard term used in data warehousing, so we can rule it out. Next question. An alternate key in database table is also called. What is a primary key? It's a specific candidate key chosen to uniquely identify records in a table. What about candidate key? It's a set of attributes that uniquely identifies a record in a table. What about super key? A set of attributes that can uniquely identify records in a table, but it may contain extra attributes not needed for uniqueness. What about foreign key? An attribute in one table that links to the primary key in another table, creating a relationship between the tables. So they are asking for alternate key in the database table. We know every database table must have primary key. If a primary key is not present, which key can act as a primary key? Candidate key can act as a primary key. Can you place super key in place of primary key? No, because they say it may contain extra attributes that are not needed for uniqueness. So we cannot choose it. Foreign key is actually the attribute which is having the values of another table's primary key. So this can also be not taken as alternate key. A candidate key is sometimes referred to as an alternate key because it is an alternative option for uniquely identifying a record in a table. A table can have multiple candidate keys, but only one of them is selected as the primary key. The remaining candidate keys serve as alternate options for the primary key, hence we have the term alternate key. Option number 2, candidate key, will be the right answer. When you are sure about what will take the place of primary key, you should be sure what keys cannot take the place of primary key. Next question. The degree of a relation in database is the number of tuples, the number of attributes, the number of values, the number of keys in a relation. The degree of a relation refers to the number of attributes in a table. Option number 2 will be the right answer. It indicates how many fields or properties each record in the table has. Actually, we are not concerned about the number of tuples. Tuples in the sense the records or the rows you can take. We are not concerned about the count of rows. And what are these values in domain? So if you take a domain of integer, there will be lots of values. That cannot be called as degree of a relation. You can rule out this. The number of keys in a relation. Certain table will have only primary key. Certain tables will have primary key, unique key. So again you cannot have a specific name for it. And the number of rows can be increased, can be decreased using insert and delete operations. So this can also be not called as degree of a relation. When you say something as a degree of a relation in database, that should be constant for all the records. So it will indicate how many fields or properties each record in the table has. Next question. What will be the right sequence of the phases of database design? So this question has been repeatedly asked in 2 of the previous year question paper. Now we will see a diagram relating to it. Requirements collection and analysis is the first step. It is available in D. Then we have conceptual design, which is B. Then we have logical design. This is where the data model mapping occurs. This is given by C. And finally we have physical design, which is A. We have the order D, B, C, A. Option number 2 will be the right answer. So this question has been already explained in earlier question paper solution video. So I am skipping explanation as of now. Which of the following is false statement? Let's start with A. An all key relation is always in BCNF since it has no functional dependencies. A relation where every attribute is a part of candidate key is always in Boyce-Codd normal form, which is BCNF. When we were solving for functional dependencies question of a relation in previous year question paper. When the candidate key is completely present in the left hand side of a functional dependency, then we can say that particular relation is in BCNF. So taking that point into consideration from the previous learning, A is definitely true. We are asked to find the false statement. We know A is true. We can rule out option 1 and 2. Let's go through the B statement. A relation that is not in 4NF due to non-trivial multivalued dependency must be decomposed to convert it into a set of relations in 4NF. When the relation which has non-trivial multivalued dependency is not in 4NF, automatically to convert it into 4NF, we have to decompose it into a set of relation. So this is also true. Now let's go for C. The decomposition removes the redundancy by the multivalued dependency. This decomposition breaks down the original relation into smaller normalized relations that follow 4NF. Other two means we can say it follows 4NF, thereby eliminating the redundancy and ensuring data integrity. So C is also true. From this we can also rule out fourth one. What about D? 3NF is stronger than BCNF. When you take the normal form, we have 1NF, 2NF, 3NF, BCNF, then we go for 4NF. As for this question, I am telling you, Boy's chord normal form is actually stricter than third normal form. Every relation in Boy's chord normal form is also in third normal form. So only after passing to this stage we are coming here. But not every relation in 3NF is necessarily in BCNF. So when you take BCNF, we can say it is already present in 3NF. Take 3NF, we can say it is already present in 2NF. When you take 2NF, we can say it is already present in 1NF. Every 3NF will definitely be in 2NF. This is how we can say. If that is the case, 3NF cannot be stronger than BCNF. The reverse is actually true. BCNF is stronger than 3NF, we can say. So D is false. Option number 3, D only will be the right answer. But that is the false statement. Here, stronger than BCNF can be taken to be stricter. So here, which is stricter? BCNF is stricter. So this statement is false. Next question. Insert command is used to add a single tuple to a relation, add multiple tuples to a relation, add values to specific attributes, insert new table. In SQL, we have a command called create table. So we can always create a table. We can never insert any table. If you take out D, you can remove fourth option. Insert command is generally used to add a single row at a time or multiple rows at a time. Both are possible. So definitely A and B are in. When we have two options inside the solution, one is also ruled out. Now we have to check whether C is in the solution or not. When using the insert command to add a new row, sometimes we specify values only for certain columns. The rest of the columns will be allowed to take default values. Insert into table name, we can specify column names and then give the values of those columns alone. Imagine there are 3 columns in a table. You can supply values to 2 columns at a time. That is what they have given as add values to specific attributes. This is only about adding values and not about updating values. Since we can add values to specific attributes similar to this syntax, we can take C also in the solution list. So we can rule out option 2 and go with option 3, A, B, C only as the right answer. To update values in specific attributes of existing rows, the update command is used instead. When you want to overwrite a particular value or replace a particular value, you can go for update operation. But the word they have used here is add. You are actually adding a row with specific values. It means values are given to certain attributes alone. Next question, match the list 1 with list 2. Project join normal form. Fifth normal form is also known as project join normal form or PJNF. A will be mapping to 2. A2 is available only in one of the option. So we can rule out the other 3. Option number 1 will be the right answer. What about the lost update problem? The lost update problem is a concurrency issue that occurs in database systems when 2 or more transactions simultaneously update the same data item, leading to one update being unintentionally overwritten by another. So what is this lost update? One update is lost because it is being overwritten by another update. The lost update problem B will be mapping to concurrency in 1. B is mapping to 1. What about C? Discretionary access control. DAC is a type of access control mechanism in which the owner or creator of an object, you can take the creator of a file or a creator of a database, has the authority to determine who can access it and what kind of operations they can perform on it. So for what purpose are they restricting? It is for security purpose. So we have C mapping to 4. What about D? Data manipulation language. This will be mapping to SQL. D is mapping to 3. So in SQL we have DDL, data definition language, DML, data manipulation language, and DCL, data control language. A2, B1, C4, D3. Option number 1 will be the right answer. Next question, match the list 1 with list 2. The terms in list 1 are from big data. Hadoop distribution file system. This is HDFS. What is the term in list 2 that is connected to Hadoop? Name node. A will be mapping to 3. Hadoop distributed file system uses the name node to manage the metadata and directory structure of the file system. So this is how we are connecting Hadoop file system and name node. A3 is available in 2 of the options, so we can rule out the other 2 options. What about veracity? In the context of big data, veracity refers to the quality and trustworthiness of the data. So B will be mapping to 1. B1 is available in both the options again. Next we'll move on to Apache Pig. Apache Pig is a high-level platform for creating MapReduce programs and it was developed by Yahoo. C will be mapping to 4. C4 is available in option 3, so we are ruling out option 2 also. What about Apache Hive? Apache Hive is a data warehousing tool that facilitates querying and managing large data sets, and it was initially developed by Facebook. So D will be mapping to 2. D2 is available here. So we are going with option 3. A3, B1, C4, D2 as the right answer. In this channel you have data science series playlist. It's a short playlist with 3 videos. In that if you take the first video you have content about big data. The video is available in Tamil language but the content inside the video are completely in English so that any language person can understand it. With this we are completing Unit 4 solutions. Let's solve Unit 5 System Software and Operating System questions. Match the list 1 with list 2. The RAID level details are given in list 2. RAID 0 is for non-redundant stripping. RAID 1 is for mirror disk. A will be mapping to 2. RAID level 1 for disk mirroring. RAID 2 will be memory style error correcting code. B will be mapping to 4. ECC organization. ECC will be error correcting code. RAID level 3 will be bit interleaved parity. C will be mapping to 1. Bit interleaved parity organization. RAID level 4 is block interleaved parity. D will be mapping to 3. Block interleaved parity organization. RAID level 5 will be block interleaved distributed parity and RAID level 6 will be P plus Q redundancy. This has been a repeated question in few of the previous year question papers. We have A2 in two of the options, so we can remove 3 and 4. Then we have B4. A2, B4 is available only in option 2. We will even rule out option 1. Option number 2 will be the right answer. Then we have C1 and D3 also. Next question. Given the following processes with their times and priority, lower number indicates higher priority. Which of the following is a value of average waiting time using priority scheduling algorithm? In priority scheduling algorithm, the processes will be arranged as per priority. So out of 3, 1, 4, 5, 2 in the priority column, which is the lowest number here, it is 1. So definitely this particular process will have higher priority. So let's arrange the processes as per priority order. P2 will come first, then we have P5, then we have P1, then we have P3 and then we have P4. Now they are asking for the average waiting time. It means you have to calculate the waiting time of every process, sum them up and divide it by the number of processes. So we will start with P2 because it is going to get executed first. What is the waiting time of P2? When P2 enters, it automatically gets executed. So the waiting time will be 0. What about P5? P2 has a burst time of 1. After P2, P5 will start executing. So it has to wait for 1 unit of time. What about P1? P2 has a burst time of 1 and P5 has a burst time of 5. 1 plus 5 is equal to 6. So it has to wait for 6 units. What about P3? Along with 6, you have to add 10. 1 plus 5 plus 10. 10 plus 6 will give 16. So P3 has a waiting time of 16. What about P4? 16 plus 2. The waiting time will be 18. Now we have to sum the waiting time. 0 plus 1 plus 6 plus 16 plus 18, which is equal to 7, 23. 23 plus 18 will give 41. How many processes are there? Overall 5 processes are there. So 41 divided by 5. This will give you the average waiting time. 41 divided by 5 will give you 8 5s are 40.2. 8.2 will be the right answer. It is available in option number 4. Option number 4 will be the right answer. Next question. If the virtual memory size is 32 MB and a physical memory size is 4 MB with a page size of 2 KB, calculate the number of frames available in physical memory. Here the question is about physical memory. So we are not going to touch this virtual memory size data. This will not be needed for this particular question. Number of frames is given by the size of physical memory divided by page size. What is the size of physical memory? It is 4 MB divided by the page size is 2 KB. Numerator and denominator are in different units. We know 1 kilobyte is equal to 1024 bytes. 1 megabyte is equal to 1024 kilobytes. What we can do is we can convert the numerator to kilobyte and thereby cancel both the units in numerator and denominator. So let's have 4 as it is. Instead of megabyte, we will go with 1024 kilobyte divided by 2 kilobyte. Now kilobyte and kilobyte unit will get cancelled. 2 2s are 4. So you have 2 into 1024 in the numerator. There is nothing in the denominator. What is 1024 into 2? It is 2048. So what will be the number of frames? It will be option number 2, 2048. Option number 2 will be the right answer. Next question. Which of the following does not interrupt a running process? Device, timer, scheduler, power failure. Now we will look about all the options. Devices can interrupt a running process. For example, when an I/O device like a keyboard or mouse needs some kind of attention, it generates an interrupt to notify the processor, causing the running process to be temporarily halted. So whenever there is a device that is requesting for a service, it always generates an interrupt to the processor. So definitely device will be interrupting a running process. They are asking for does not interrupt. So we can rule out device from the answer list. Then we'll go for timer. A timer interrupt is used by the operating system to preempt the current running process. So this is also going to interrupt a running process. So this will also not be the answer. This timer interrupt allows the OS to enforce time sharing and ensure that all processes get a chance to execute, preventing any single process from taking control over the CPU. What about scheduler? The scheduler does not interrupt a running process. Instead, it decides which process will run next when the current process either completes or is preempted by an interrupt, like a timer or a device we can say. The scheduler's job is to manage the execution order of processes and they do not directly interrupt them. In that case, we can say it does not interrupt a running process. What about power failure? A power failure results in an immediate halt of all processes since the system loses power. This is an abrupt and involuntary interruption that affects all running processes. Whether it is voluntarily done or involuntarily done, here there is an interruption occurring. So definitely power failure will also interrupt a running process. So we can rule out even option 4. So what will be the right answer? Option number 3, scheduler will be the right answer. So when you are learning which does not do some task, always learn about the other options which are involved in doing that particular task, because it might be helpful for you in some other question paper. Next question. The entire set of parameters including return address that is stored for a procedure invocation is referred to what? Stack frame, stack base, stack limit, stack record. So we will learn about all the 4 options. A stack frame, also known as an activation record, is the entire set of parameters including the return address, local variables and other information that is stored when a procedure, that is when a function is called. The entire set of parameters including return address, that is what is given here. Entire set of parameters including the return address is stored when the procedure is called is equated to stored for a procedure invocation. Invocation means it's calling. Stack frame will be the right answer. Option number 1 will be the right answer. Each procedure call creates a new stack frame, or we can say a new activation record, which is pushed onto the stack and popped off when the procedure completes. So if you take a stack like this, say for example there are 2 procedures P1 and P2 getting executed. The first call is P1, so we will have P1 in the stack and P1 will call P2, then we will have P2 here. Once P2 gets completed, it is popped off and the control moves to P1. Once P1 is also done, it will be removed from the stack. So this is actually used to maintain the order of procedure calls also we can say. What about stack base, stack limit and stack record? The stack base is a pointer that refers to the base or starting address of the stack. It is not the entire set of parameters for procedure invocation, but it's just an address indicating where the stack begins. So this is not the answer. The stack limit refers to the maximum allowable size of the stack or the boundary beyond which the stack cannot grow. This is a constraint to prevent stack overflow but does not represent the set of parameters for a procedure invocation. Actually, there is no term like stack record. Actually, we call it as activation record and not stack record. While stack record can sometimes be interchangeably used with stack frame, it is actually less commonly used in this context. So, we cannot consider this particular term as an option at all. Next question. Consider the following graph of disk scheduling and identify the disk scheduling algorithm represented by this graph. They have given the queue as 84, 125, 11, 36, 170, 20, 172, 45. From the graph you can understand the head position is actually given in 28. We will see the graph as per every scheduling algorithm that is given in the 4 options. Whichever representation is matching with the question graph, that particular algorithm will be the answer. Let's start with shortest seek time first, SSTF. This selects the request with the minimum seek time from the current head position. Taking the first position as 28, we have two ways. We can either go to 36 or to 20. 28 plus 8 will give you 36 and 20 plus 8 will give you 28. So both are possible here. After 36, if you go, you will have 45 with 9. Then here we have again 9, 11. From 45 you have to move to 84. What is 84 minus 45? 14 minus 5 is 9. 7 minus 4 is 3. At a distance of 39 you have 84 here. What about 45 and 20? At a distance of 25 you will have 20. Then again with a distance of 9 you will have 11. After 11 you have to directly go to 84. What is 84 minus 11? It will be 73. So from 11 there is only one way to move forward, that is 36. So you have only 25 movements here. From 36 it is 45. From 45 it is 84. So we will take this particular order in SSTF. 28, 20, 11, 36, 45, 84, 125, 170, 172. This will give the shortest seek time compared to other ways. Is the graph moving towards 20? No. So option number 1 is wrong. What about the next algorithm? Scan. In the scan algorithm, the disk arm starts at one end of the disk and moves toward the other end, servicing request as it reaches each cylinder until it gets to the other end of the disk. At the other end, the direction of head movement is reversed and servicing continues. They are saying it will move till the other end of the disk. It means what is the end here? 199. So we will start with 28, then move towards 36, 45, 84, 125, 170, 172. From 172 we have to touch this 199. From 199 we have to reverse the direction of the head movement, and then servicing continues means you have to start with 20 and then move to 11. Is this particular graph touching 199? No. Scan is also out of the race. What about C-scan? C-scan moves the head from one end of the disk to the other, servicing request along the way. When the head reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. It means once it touches the other end, which is 199, it has to immediately return to the beginning of the disk without servicing any request. After 172 it is moving to 11, but it is not touching 199 or 0, which is in the path of C-scan movement. So C-scan is also not in the option. What about C-look? C-look is similar to C-scan but does not move to the end of the disk, but the arm goes only as far as the final request in each direction. It means 172 is the final request towards one end and 11 is the final request in the other end. So the travel will be till 172 in this end and 11 in this particular end. Then it reverses direction immediately without going all the way to the end of the disk. It means it will go only till 172 and not to 199. It will reverse direction immediately when it finds the first request. You have 11 in the first place. Without going all the way to the end of the disk, it will stop at 11 but it will not go to 0. Now you can have the order as 28, 36, 45, 84, 125, 170, 172. From 172 we are moving to 11. From 11 we are going for 20. This graph is also giving the same order. 28, 36, 45, 84, 125, 170, 172. Without touching the other end 0, it is stopping at 11. Then it is servicing the request at 20. So this graph representation is equated to C-look disk scheduling algorithm. Option number 4 will be the right answer. In order to answer this particular question, you should have understanding about all the disk scheduling algorithms. Next question. From here we are going to answer for a set of 5 questions. Consider the following set of processes with the arrival time and length of CPU burst time given in milliseconds. What is the average turnaround time for these processes with first come first serve scheduling algorithm? The first question is with respect to FCFS. So in whatever order it is arriving, it will be executed in the same order. This is the order of execution. What is turnaround time? It is completion time minus arrival time. We have to know the completion time in order to calculate the turnaround time. At time 0, P1 is entering. It is executing for 5 milliseconds. What is the completion time? It is 5. P2 actually arrived at 2, but till 5 it didn't get the CPU. So from 5 it has to run for a burst time of 3. This will run up to 8. The completion time of P2 will be 8. From 8, P3 will be running for 2 burst time. This will be 10. From 10, P4 will run for 3 milliseconds. This will be 13. From 13, P5 will run for 1 millisecond. So this will be 14. So this is running for 5 burst time. This is for 3 burst time. This is for 2. This is for 3. And this is for 1. Since the process is served in first come first serve scheduling algorithm, we are going with the same order as per the arrival time. Now we have the completion time. So what we should do for turnaround time? It is completion time minus arrival time. 5 minus 0 will give you 5. 8 minus 2 will give you 6. 10 minus 2 will give you 8. 13 minus 5 will give you 8. 14 minus 6 will give you 8. They are asking for average turnaround time. This will be 5 plus 6 plus 8 plus 8 plus 8 divided by how many processes are there? 5 processes are there. 8 plus 8 plus 8 is 24. 24 plus 6 is 30. 30 plus 5 is 35. 35 divided by 5 will give 7, which is equated to 7.0 milliseconds. Option number 3 will be the right answer. Next question. What is the average waiting time for these processes with non-preemptive shortest job first SJF scheduling algorithm? What is actually non-preemptive? When P4 is executing, P5 is entering with 1 burst time. If they say it's a preemptive SJF, immediately the control moves to P5. But they have told it is non-preemptive. It means once a particular process gets the CPU, until it completes, it will not allow any other process inside. Once a process starts executing, it runs to completion before another process is selected. It doesn't get interrupted or swapped out is what we mean by non-preemptive. Let's take the tabular column here. The arrival time and the burst time is given as it is. We are going by shortest job first. Just don't go with the burst time. We cannot go and select P5 initially because P5 is only arriving at 6 millisecond. Which process is actually arriving at 0th millisecond? P1. So P1 will get the first execution slot. What is the burst time of P1? It is 5. So P1 will be completing at 5. We will have 5 here in completion time. P2 has arrived at 2. P3 has arrived at 2. Since the time is actually 5 millisecond, P4 has also arrived at 5 millisecond. So we will have P4 is equal to 5. Now just consider the burst time alone. P2 is 3, P3 is 2 and P4 is 3. Which is having the shortest job here? P3 is having shortest job. So P3 will be selected next. For how much burst time it should execute? For 2 burst time. So 5 plus 2 will give you 7. The completion time of P3 will be 7. Now at 7 milliseconds, we already have P2 that has been arrived at 2 millisecond. P4 that has arrived at 5 millisecond, and we have P5 also at 6 millisecond. So now this is the arrival time. What about the burst time here? P2 has 3 burst time, P4 has 3 burst time, and P5 has 1 burst time. Which is having the shortest job? P5. So we are going with P5 now. P5 will execute for 1 burst time and the completion time will be 7 plus 1, which is equal to 8. After P5 we have only two options. P2 with 3 burst time, P4 with 3 burst time. So based on the arrival criteria, we will first execute P2 itself. P2 will run for 3 burst time 11 and P4 will be alone remaining here. So P4 will run last for 3 milliseconds and thereby complete at 14. So P2 will complete by 11 and P4 will complete by 14. Now what is turnaround time? It is completion time minus arrival time. These two columns have to be taken now. 5 minus 0 is 5, 11 minus 2 is 9, 7 minus 2 is 5, 14 minus 5 is 9, 8 minus 6 is 2. What about the question? They have asked about the average waiting time. So here we can use this particular formula, turnaround time minus burst time. These two columns can be considered here. What is 5 minus 5? It is 0. So P1 has 0 waiting time. It is done. What about P2? 9 minus 3 is 6. Why P2 is having 6 waiting time? It's because P2 is getting the slot only at 8. But when did it come? It came at 2. So 8 minus 2 will give you 6. You can even compute in that way if your mind works better during examination. But if you know this formula, it will be easy for you to compute. Next, what about P3? It is 5 minus 2, which is 3. So P3 is actually arriving at 2nd millisecond and it gets the CPU at 5th millisecond. So 5 minus 2 will give you 3 only. What about P4? 9 minus 3 is 6. P4 arrives at 5 but it gets the CPU only at 11. 11 minus 5 will give you 6. What about 5? 2 minus 1 is 1. P5 is arriving at 6 but it gets the CPU at 7th millisecond. So it is waiting only for 1 millisecond. If you are able to get it in that way, you can go by that. If you are not able to process it, then you can go by this formula. There is no compulsion that you have to do only in this way. But ultimately you should get the right waiting time. That alone you have to keep it in the mind. What about the average waiting time now? Sum them up. 0 plus 6 plus 3 plus 6 plus 1 divided by the number of processes, which is equal to 5. 6 plus 3 is 9, 9 plus 6 is 15, 15 plus 1 is 16. 16 divided by 5. 5 3s are 15, then we have 0.2 for 10. 3.2 millisecond is the average waiting time here. Option number 4 will be the right answer. Next question. Find the average weighted turnaround time for these process using highest response ratio next algorithm. HRN algorithm they have given. Actually it is HRRN algorithm. HRRN is a non-preemptive scheduling algorithm where the process with the highest response ratio is selected next. What is this response ratio? Waiting time plus burst time divided by burst time. Why is this particular response ratio useful? Because sometimes a process may come earlier, but due to its long burst time, it has to wait for a very long time. In order to not allow process suffer more of starvation, this response ratio will be useful. What is the question about average weighted turnaround time? So for weighted turnaround time, we need turnaround time divided by burst time. What is turnaround time? It is completion time minus arrival time. We have to find the completion time, turnaround time, and from there we have to get weighted turnaround time. Let's take 0 millisecond first. At 0 we don't have any process, so P1 will be getting the CPU. What is the burst time of P1? It is 5. So till 5 milliseconds it is getting executed. Now which process has to be selected next? At 5 milliseconds, what are the processes available? P2, P3 and P4. The arrival time for P2 and P3 will be 2 and the arrival time for P4 will be 5. So at 5 milliseconds these three processes are ready. We have to find the response ratio of these three processes. So what is the arrival time here? Let me write it here. It is actually 2, 2 and 5. Let's take the time here as at 5. Just to find out this particular slot, we are going with this particular calculation. What is the waiting time of process 2? It arrived at 2 and now the time is 5. So 3 milliseconds. P3 is also waiting for 3 milliseconds. P4 arrived at 5 only and now the time is 5 only. So 0 milliseconds of waiting time. What is the burst time of these processes? P2's burst time is 3. P3's burst time is 2. P4's burst time is 3. Now we have to find the response ratio. Waiting time plus burst time divided by burst time. 3 plus 3 divided by 3. It is 6 by 3 which is equal to 2. Then we have 3 plus 2 divided by 2. It is 5 divided by 2 which is equal to 2.5. What about P4? 0 plus 3 divided by 3. 3 divided by 3 will give you 1. We have to select the process with the highest response ratio. Which is having the highest value here? 2, 2.5, 1. P3 has the highest value. So we have to go with P3 based on this particular value. So P3 will get the CPU next. What is the burst time of P3? It is 2. 5 plus 2 will give you 7. At time 7, what are the processes available? P2 is there, P4 is there and P5 is also there. What is the arrival time? P2 is 2, P4 is 5, P5 is 6. What about waiting time? Now the time is 7 milliseconds. 7 minus 2, it has waited for 5 milliseconds. 7 minus 5, it has waited for 2 milliseconds. Then 7 minus 6, it has waited for 1 millisecond. What about the burst time? P2 is 3, P4 is 3, P5 is 1. Now we have to calculate the response ratio. 5 plus 3 divided by 3. 8 by 3, this will give a value of 2.666. It goes on. So we can round off to 2 decimal places, 2.67. What about 2 plus 3 divided by 3? It is 5 divided by 3. Here we have 1.66. So we can round off to 1.67 here. What about P5? 1 plus 1 divided by 1 will give a value of 2. Now 2, 1.67, 2.67. Which is having highest response ratio? This process. We are selecting P2 here. P2 will get the next slot. What is the burst time of P2? It is 3. 7 plus 3 will give 10. So P1 is completing at 5. P3 is completing at 7 and P2 is completing at 10. At 10 milliseconds. What processes are there? P4 and P5 are there. P4 arrived at 5 and P5 arrived at 6. What about waiting time? The current time is 10. 10 minus 5 is 5. 10 minus 6 is 4. What about burst time? It is 3 for P4 and 1 for P5. What is the response ratio? 5 plus 3 divided by 3. 8 divided by 3 will give 2.67 and 4 plus 1 divided by 1 will give 5. Which process is having highest response ratio now? 5. So P5 will be selected now. We'll go with P5. What is the burst time? 1. 10 plus 1 is 11. P5 is getting completed by 11 milliseconds. What is the remaining process? It is P4. So let's have P4 here in the final slot. What is the burst time? It is 3. So 11 plus 3 will give you 14. The completion time is 14 here. What about turnaround time? It is completion minus arrival time. 5 minus 0 is 5. 10 minus 2 is 8. 7 minus 2 is 5, 14 minus 5 is 9, 11 minus 6 is 5. Now we have to find the weighted turnaround time. It is these two columns. Turnaround time divided by burst time will give you weighted turnaround time. 5 divided by 5 will give you 1. 8 divided by 3 will give you 2.67. We have already calculated here. Just go with 8 divided by 3. 3 2s are 6. You have 20 here. You have 0.6. Again you keep having 20 again and again. So instead of going as 2.666, we are just rounding off to 2 decimal places. That's why we have 2.67. Then we have 5 divided by 2, which will give 2.5 exactly. Then we have 9 divided by 3, this will give you 3. 5 divided by 1 will give you 5. So what is the average weighted turnaround time? 1 plus 2.67 plus 2.5 plus 3 plus 5 divided by 5. 3 plus 5 is 8, 8 plus 1 is 9, 9 plus 2.5 is 11.5. 11.5 plus 2.67 will be 7, 5 plus 6 is 11, 1 plus 1 is 2, 2 plus 2 is 4, 14.17 in the numerator. 14.17 divided by 5. 5 2s are 10, we have 4, then we will have a point, it's 41, 5 8s are 40, 41 minus 40 is 1, then we have this 7, 5 3s are 15 and 7 minus 5 is 2. Then we have 5 4s are 20. So the value is 2.834 milliseconds. This will be the average weighted turnaround time. 2.834 milliseconds is available in option 2. Option number 2 will be the right answer. Next question, calculate the average response time for these processes with non-preemptive priority scheduling algorithm. Priority of the process are as follows, and consider that all the processes came at 0 time. Note, low numbers represent high priority. What does this mean? All processes came at 0 time. We are not going with this arrival time. They are saying the arrival time of all the processes will be 0 only. So at a stretch you have to consider all the 5 processes, but the execution will go with priority scheduling algorithm. So you have to choose the process with the highest priority. So P2 is having the highest priority here. In non-preemptive scheduling algorithms, the response time is typically the same as the waiting time, because a process starts executing as soon as it is scheduled. So the order will be P2 first, then the second one will be P5, then we have P1, then we have P4 and finally we have P3. Now based on this we have to find the average response time. In non-preemptive scheduling, the response time is equal to the waiting time, because once the process gets the CPU, until it completes it will not get out of it. In preemptive scheduling, what happens is, let's take an example, P6 is coming in and because of some priority, P7 is getting the CPU and then P6 is again getting the CPU. This waiting time is what we can call as response time. We are not worried about when it is going to complete. So there are possibilities of splitting up of the execution of the same process in preemptive scheduling. In non-preemptive scheduling, such a scenario will not happen. So the response time is typically the same as the waiting time. So if they have asked you average response time, it means you have to calculate the average waiting time. So let's start from 0. So every process is going to have 0 arrival time. So the first process here will be P2. P2 will run for 3 milliseconds. So the completion time of P2 will be 3. After P2 we have P5 for 1 millisecond of burst time. So this will be 4. P5 will complete at 4. After P5 it is P1. It will run for 5. 4 plus 5 will give you 9. So it will complete at 9. After P1 it is P4. So 9 plus 3 will give you 12. So this will be 12. After P4 it will be P3 finally. P3's burst time is 2, so it will complete at 14. Now we have to just compute the waiting time. P2 does not wait for any time, so the waiting time here it is 0. P5 is waiting for 3 milliseconds and starting, so it is 3. So this is P5's wait time. So here at 0, P1, P2, P3, P4, P5 all are ready. Now P5 is starting at 3 means what is the wait time? It is 3. P1 is starting at 4 means what is the wait time for P1? It is 4. P4 is starting at 9 means what is the wait time? It is 9. P3 is starting at 12 means the wait time is 12. Turnaround time will be equivalent to completion time, because turnaround time will be completion time minus arrival time, which is 0 in all the cases. So this will be automatically the turnaround time. Now what is wait time? It is TAT minus BT, that is turnaround time minus burst time. Just compute these two columns. 9 minus 5 is 4, 3 minus 3 is 0, 14 minus 2 is 12, 12 minus 3 is 9, 4 minus 1 is 3. So let's take average response time is equal to, we have to consider 4 plus 0 plus 12 plus 9 plus 3 divided by 5. 4 plus 12 is 16, 16 plus 9 is 25, 25 plus 3 is 28 divided by 5. 5 5s are 25, we have 3, it is 0.6 for 30. 5.6 milliseconds will be the average response time. Option number 1 will be the right answer. Next question, in fact the final question of the set of 5 questions. When we apply shortest job first scheduling policy algorithm, process P2 faces partial starvation and waits for the longer time to execute. Which one of the following algorithms addresses this problem? So let's actually take every algorithm now. In round robin scheduling, each process gets an equal time slice or a quantum in a cyclic order. While this algorithm prevents starvation and is fair in terms of time allocation, it may not be the most efficient for minimizing response time or turnaround time for processes with shorter burst times. So this is not going to do much change, but it will not allow any process to starve. That is also true. What about priority scheduling? In priority scheduling, the process with the highest priority is selected for execution. While this can be effective, this can also lead to starvation if lower priority processes are constantly preempted by higher priority ones. Take for example, if a process keeps coming with highest priority, when you have something in low priority, it will never get a chance to get executed. That is what they say here. What about least completed next scheduling algorithm? So this is for option 1, this is for option 2 and this is for option 4. This algorithm is not commonly defined in classic scheduling. It might imply choosing the process with the least progress or shortest remaining time, similar to SRTF algorithm, shortest remaining time first. Like shortest job first, it can lead to starvation for longer processes if shorter processes keep arriving. Definitely starvation for longer processes will occur if upcoming processes are completely having shorter burst times. So let's see the P2 process in SJF and the P2 process in highest response ratio next algorithm. This is the order of arrival. As they say, it faces partial starvation. Actually, it should have started second, but it is starting fourth is what they say in SJF. This is the situation explained in the question. This algorithm is actually moving the P2 process from the fourth slot to the third slot. So HRRN algorithm will address this problem. HRRN considers both the waiting time and burst time when selecting the next process to execute. What is response ratio formula? Waiting time plus burst time divided by burst time. So it is considering both waiting time and burst time when selecting the next process. By selecting the process with the highest response ratio, HRRN balances between short and long burst time processes, ensuring fairness. So they are saying how it is addressing this particular problem. This ensures that processes that have been waiting for a long time get a higher priority, thus preventing starvation. At one point of time, this particular ratio value will be higher due to higher waiting time. At that time, it will get some kind of higher priority in response ratio calculation, and thereby it will be given the CPU. So which algorithm actually addresses this problem is highest response ratio next algorithm, which is available in option 3. Option 3 will be the right answer. I have given you the explanation of round robin priority with respect to starvation of processes. And least completed next is actually not a part of CPU scheduling, but just based on the term least completed, we can compare it to shortest remaining time first or shortest job first. So considering this case, definitely it will lead to starvation is what they say. But when you don't have an algorithm with this term, you need not consider them at all. Compared to HRRN, round robin and priority scheduling will not address this problem. So we can even rule out option 1 and 2. With this, we are completing Unit 5 solutions. Let's solve Unit 6 software engineering questions. Which one of the following is the correct estimation model based on software equation? We have two terms here, estimation model and software equation. What are they actually? An estimation model for computer software uses empirically derived formulas to predict effort as a function of LOC or FP. LOC is lines of code and FP is function points. The software equation is a dynamic multivariable model that assumes a specific distribution of effort over the life of a software development project. This equation is nothing but the effort towards some software development project. So they have given this in the form of equation. The right equation will be E is equal to LOC into B power 0.333 divided by P the whole power 3 into 1 divided by T power 4. This equation is perfectly matching in option 2. Option number 2 will be the right answer. Now let's see what are the variables used in the equation. E is equal to effort in person months or person years. This T is the project duration in months or years. The capital B is special skills factor. And the capital P is productivity parameter that reflects overall process maturity and management practices, the extent to which good software engineering practices are used, the level of programming languages used, the state of the software environment, the skills and experience of the software team, the complexity of the application. So just have an idea about all the variables that are used in the equation. It might be useful for you in some other question paper. Next question. Collaborative document inspection technique is used for. So just based on the question, we can say that it does not belong to integration testing and black box testing. So these are testing the software product, but here it is document inspection technique. So how does this inspection technique occur? By means of collaboration. So you can take the individual meaning of these particular terms and then get an idea. We have to check whether it is requirement validation process or requirement verification process. Collaborative document inspection is a systematic and structured process where multiple stakeholders work together to review and assess the quality of a document. Requirement validation ensures that the documented requirements reflect the actual needs and expectations of the stakeholders. Requirement verification ensures that the requirements document complies with predefined standards, guidelines and criteria. These are actually predefined standards and criteria. For this particular verification, you don't need a collaboration and all. You can just check whether they are agreeing to the norms or not. But with respect to validation, you have to check whether it is reflecting the actual needs and expectations of the stakeholders. So when you take stakeholders into consideration, here collaboration is possible. We can conclude collaborative document inspection technique is used in requirement validation process. Option number 1 will be the right answer. We can even rule out option 2. Understand why we are ruling out option 2. It is because you have a set of standards and you have a set of criteria. You don't need to collaborate with someone. You can just check the criteria and say whether it is complying or not. That is not a collaborative process is what I am trying to tell you. But here in validation process, they say multiple stakeholders work together, which is actually matching with this particular statement here, reflecting the actual needs and expectations of the stakeholders. Stakeholders in the sense people who are involved in the projects. You can take it in a broader aspect. Collaborative document inspection is a crucial technique used to ensure that the documented requirements accurately reflect the needs and expectations of the stakeholders. What about integration testing and black box testing? The integration testing focuses on verifying the interaction between integrated components or systems. The emphasis here is on dynamic testing rather than document inspection. So this does not involve inspection is what I told you earlier. What about black box testing? It's a technique where the tester evaluates the functionality of the system without looking at the internal code structure. When you work with the code, that is white box testing. When you work with the behavior of the system, that is black box testing. While test cases and scripts can be reviewed, this process does not typically involve collaborative document inspection. Next question, which one of the following is not the part of requirement management? From this we can understand that 3 of the options are a part of requirement management. Now let's see about every option. Features traceability table. This table is a part of requirement management as it helps in tracking the relationship between features and the corresponding requirements. It ensures that all features are covered by the requirements and helps in managing changes to requirements. So whenever you take a particular software, features are important. So option 1 is definitely a part of requirement management. What about the next table? Dependency traceability table. It is used to track dependencies between different requirements, which helps in understanding the impact of changes to one requirement on others. If we modify or if we introduce some change in one requirement, how far it is going to affect other is what we say as dependency factor. So definitely dependency traceability is also a part of requirement management. Next one is interface traceability table. It tracks the interfaces between different system components and their corresponding requirements. This ensures that all interfaces are properly defined and managed. Take 2 modules. If you want to communicate with the module, you will definitely need an interface. We can keep it as simple as possible. So definitely option 3 is also a part of requirement management. What is left out here? Option 4. From this we can mark option number 4, page traceability table as the right answer, but that is the only option that is not the part of requirement management. A page traceability table is not a standard practice in requirement management, as the page traceability concept is not directly related to tracking requirements. Next question. Software testability is simply how easily a software program can be tested. Which one of the characteristics does not lead to testable software? Let's see the options one by one. Observability refers to how easily you can monitor and measure the internal states of a software system through its outputs. High observability helps in identifying issues during testing, making it easier to understand the system's behavior. Just based on the outputs observation, you are able to monitor and measure the internal states of a software system. So definitely this characteristic is present. What about controllability? It is the degree to which a tester can control the state of the software under test. High controllability allows testers to set up conditions, inputs and configurations to effectively test different scenarios. You are actually controlling what kinds of conditions can be in the form of test cases, what inputs to give, what kinds of configurations you can make. So this is controllability, and definitely it is a characteristic of testable software. What about understandability? It is how easily the software's behavior and logic can be comprehended. Comprehended in the sense it can be understood. High understandability allows testers to better grasp what the software is supposed to do, making it easier to design and execute tests. So definitely understandability is also a characteristic of testable software. Just looking at the terms observation, control and understandability, you can understand that only when you are able to observe what's happening in the system, you will know what is the software system doing. You are giving inputs, you are configuring the software system, so controllability is also there. Regarding understandability, only when you understand what task is going on, you can understand what kind of test you can give to the software. Repairability is about what you are going to do with the fault part. Repairability or maintainability refers to how easily a system can be fixed or updated after identifying defects. Only when you find there is a defect, there comes the term repairability. And when you take maintainability, after delivering the software to the client, you need to maintain the project. Whether you need some updates, upgrades, or whether it has introduced some new errors, everything comes under maintainability. While important for software maintenance and evolution, it is more concerned with fixing and maintaining the software rather than testing it. When will you actually go for software testing? Before delivering the product. So if you take development process, testing occurs after implementing the particular software product. After you deliver to the client, whatever happens here comes under maintenance. So only during maintenance you will be able to repair something. So we are going with option number 3, repairability, as the right answer. Next question. Find the correct sequence of prototype software development model. So let's see the prototype development model. We are starting with communication. From there we are moving to quick plan, then to modeling, quick design, then construction of prototype, deployment, delivery and feedback. Again it's a iterative process is what they have given here. So let's start from A. Since we have given the term start, every option is starting with A. What is the first phase here? It is quick plan, and here it is given as quick play. So let's take this to be quick plan. This is E. What about quick design? It is D. What is construction of prototype? It is developing prototype, which is B. What about deployment, delivery and feedback? It is delivered to customer, which is C. So we can take the starting point to be A. It starts from here. AED BC is available in option number 2. Option number 2 will be the right answer. Next question. As per the Software Engineering Institute, the correct sequence is. This question has been repeated in previous year question papers. The Software Engineering Institute has developed a comprehensive model predicated on a set of software engineering capabilities that should be present as organizations reach different levels of process maturity. What are the different levels? We will actually term it as CMM levels, capability maturity model. That model has these 5 levels. Level 1 is initial, which is option A. Level 2 is repeatable, it is option B. Level 3 is defined, it is option E. Level 4 is managed, that is option C. Level 5 is optimizing, that is option D. A, B, E, C, D. Option number 2 will be the right answer. What is level 1? It is initial. Few processes are defined and success depends on individual effort. Level 2 is repeatable. Basic project management processes are established to track cost, schedule and functionality. What about defined? The software process for both management and engineering activities is documented, standardized and integrated into an organization-wide software process. This level includes all characteristics defined for level 2. So level 3 will include level 2 characteristics also. What about level 4 managed? Detailed measures of the software process and product quality are collected. Both the software process and products are quantitatively understood and controlled using detailed measures. Based on quantitatively understood term, what you can understand is you have some kinds of measurements and metrics that will give you some values. This level includes all characteristics defined for level 3. What about level 5 optimizing? Continuous process improvement is enabled by quantitative feedback from the process and from testing innovative ideas and technologies. This level includes all characteristics defined for the previous level, that is level 4. So this question has already been explained in those videos. So I am just telling you what are the explanation for these levels alone. Next question, identify the correct statements from the following regarding spiral model. Now let's check about the spiral model. The spiral model is a risk-driven software development process model that combines iterative development, that is prototyping, with the systematic aspects of waterfall model. So it is combining the prototype model and the waterfall model is what we can understand in a nutshell. What is prototyping? The iterative development. Here you can see it is repeating again and again, that is iteration. You have three aspects in planning: estimation, scheduling and risk analysis. From this you can understand that this model is a risk driven software development process model. Definitely B is a correct statement. Any option that does not involve B can be ruled out. The spiral model is inherently cyclic because it involves repeated iterations or spirals of planning, risk analysis, engineering and evaluation phases. These are the general phases they have given. This is with respect to the reference book diagram. The term acyclic suggests that there are no cycles, which is not accurate for the spiral model. So they say it's cyclic because it involves repeated iterations or what we call as spirals. When it is cyclic, the term acyclic is actually wrong. So C is not in the answer list. The options involving C can be ruled out. While the spiral model does aim to balance risk management and development activities by revisiting these phases iteratively, this does not make it acyclic. So they say it is definitely cyclic. The spiral model involves a set of anchor point milestones, which are critical points in the development process where key decisions are made, risks are assessed and progress is evaluated. Spiral model involves a set of anchor point milestone is perfectly right. So D is also right. We can rule out option A and we can go with B and D only as the right answer. Option 4 is the right answer. Let's check with A statement. Spiral model is an incremental process model. When you take earlier versions of certain software engineering books, they would have actually started telling that it's prototyping plus waterfall. When you take explanation kind of articles or search engine results, they will say it's an incremental process model because even in incremental process, this iterative development will take place. So let's understand one thing. As per new edition books, prototyping and spiral models are placed under evolutionary process models. So let's understand the difference between incremental model and evolutionary model. Incremental model builds the system in small, manageable increments or iterations. Each increment adds specific functionality to the system until the complete product is developed. Take for example, a product is having 5 phases or 5 pieces of modules. Every module is taken to be an increment. So you build one increment at a time. And finally, you are joining all the increments together to get the complete product is what they say here. So for every increment, you are undergoing the same set of phases and that is what you compare here to iterations. This is incremental model. If you take evolutionary model, this is an iterative approach that focuses on evolving the system based on continuous user feedback and changing requirements. Once you finish one set of iteration, you automatically get feedback and make changing requirements to it. So this process is happening in this pattern. Under evolutionary model only you have prototyping model And taking prototyping along with waterfall aspects, you are getting spiral model here. So spiral model is a part of evolutionary model and not incremental model. But when you take AI generated answers or if you go for search engine answers, they may have a word like it is also an incremental model. But this incremental model is having similar features with evolutionary model in terms of iterations. They also form a cycle, but how the cycle is formed in these two models have a difference. Incremental model work like module based. Say for example, that's what I told as an example, that there are 5 increments for this particular product. Every increment undergoes the same set of phases and finally you get the complete product. But here you don't have increment approach. Here you are evolving the system continuously by changing requirements. On the whole, you are developing in evolutionary model, but increment by increment you are adding specific functionality to the system in incremental model. There is a difference between both the models, though they share many characteristics in common. So that is why we are ruling out option A. Next question. In software engineering, Jackson's principle is based on. Actually, this person Jackson has written a book on software engineering. Only in that particular book or software engineering books which have referred this particular person's book will have these details. If you take normal software engineering books, you may not find this approach. So we have to choose only 3 out of these 5 options. Jackson's principle in software engineering is primarily based on structured programming, clear code and focusing on data structures and operations. Now let's see about option A. Designation refers to assigning specific roles and responsibilities within the code structure. So what is the designation talking about? Clearly designated roles make it easier to update or modify specific parts of the code without affecting other components, enhancing maintainability. It is giving a kind of role for a part of code. They can say you can update only this part without affecting the other part. This is designation. So A is included in the answer. What about the next one? We have definitions, which is B. Definitions focus on clearly defining data structures and operations. So this particular point is given. Defining data structures clearly ensures that the code is organized and that each part of the program knows what data it should handle. Having well-defined operations and structures ensures that the logic of the program is consistent and easy to understand, facilitating better design and implementation. Now the next point, refutable assertions. This is C. Refutable assertions involve making assumptions in the code that can be tested and potentially disproven. Assertions help in validating the correctness of the code by checking if certain conditions hold true during execution. In case if an assertion fails, this will indicate a potential bug or issue. Using refutable assertions make it easier to identify and debug problems in the code. By testing assumptions, developers can quickly pinpoint where things might be going wrong. So if you are able to test and disprove something, that is refutable assertions. You are actually working with the code here. So clear code aspect can be taken. At the same time, when you use designation, designated roles especially, that comes under structured programming, you can equate those terms. So we can include B and C also in the answer. Option number 1, A, B and C only will be the right answer. What about formal review and requirement elicitation? Requirement elicitation is you are getting the requirements from the stakeholders by means of interviews or questionnaires. You are eliciting, you are asking for the requirements or you are collecting for the requirements. So requirement collection is not related to Jackson's principle. So we are ruling out this. What about formal review? Review happens on already present things. So review is also not a part of principle. So take the clue as structured programming, clear code and focus on data structures and operations. Just keeping these three terms as hints, we are going with A, B and C. If you take Jackson's book, you will have detailed definition on all these three options: designation, definitions and refutable assertions. Next question, match list 1 with list 2. List 1 has software risk and list 2 has its uses. Let's see one by one. What about predictable risks? Predictable risks are those that are anticipated based on previous experiences or known factors. If you take a particular project and you have gained some experience and you know what kinds of errors are possible, when you are going to start a second project, you will automatically predict certain risks based on the previous experiences, what they say. A will be mapping to 4. A4 is available in 2 of the options. We can rule out the other 2. What about business risks? Business risks are associated with the potential impact of the project on the business itself. That includes financial, market and operational aspects. Strategic risks involve high-level decision making and planning that can affect the overall direction and success of the project. Actually, this risk is associated with business level is what they say. We can address business related risks through high level decision making and planning. What does high level decision making and planning say? It says they are strategic risk. So B will be mapping to 1. B1 is available in option 4, so we can even rule out option 1. What about project risks? Project risks are specific to the execution and management of the project, including timelines, budgets and deliverables. This should ensure effective staffing and coordination to manage project execution risks. So, we are involving staffing and coordination, which is equating to staffing and organization in list 2. So, C will be mapping to 2. C2 is available here. What about past project? Past project risks refer to the challenges and issues encountered in previous projects. These risks provide valuable insights that can inform the implementation process. By considering past project risk, teams can avoid repeating mistakes, leverage successful strategies, and improve the overall implementation of the current project. So you can take it like past project will help you in implementing your new one. So D will be mapping to 3. D3 is available here. A4, B1, C2, D3. Option number 4 will be the right answer. With this we are completing Unit 6 solutions. Let's solve Unit 7 Data Structures and Algorithms questions. Which of the following descriptions are true? We'll start with red-black tree. Guarantees worst case of O log n time for search, insert and delete. With red-black trees, we can perform the following operations in big O of log n in worst case, where n is the number of nodes in the trees. What are the operations? Insertion, deletion, finding predecessor, successor, finding the minimum and maximum. Finding something is what we can equate to search. Insertion and deletion are given directly as insert and delete. So, big O of log n time is perfectly right. A statement is true. The next one, tries. They are used for efficient prefix-based searches. A trie is a tree and each node in it contains the number of pointers equal to the number of characters of the alphabet. This is much faster than hash table and binary search tree representations. Tries are especially efficient for prefix searches. This point is actually given in the question. So B statement is also true. What about C, AVL tree? It's a self-balancing binary search tree with stricter balance criteria. It's just a printing mistake, so it is stricter balance criteria. What is AVL tree? This is a binary search tree with a balance condition. The difference between left subtree height and right subtree height is at most 1. At most 1 means not greater than 1. It can be at the maximum only 1. So this at most 1 is what they state as stricter balance criteria here. We are actually given the term balance condition to denote this at most 1 difference. That's why here the term is stricter balance criteria. So based on the statement we can even mark C to be true. What about D, B tree? Allows efficient search, insert, delete operations in disk-based system. If access to each node requires a disk access, then a B tree will minimize the number of disk accesses required. So regarding B tree, it is actually for disk-based system. That's why they have given it allows efficient search, insert and delete operations. The minimization factor is usually chosen so that the total size of each node corresponds to a multiple of the block size of the underlying storage device. This choice simplifies and optimizes disk access. When they say it optimizes disk access or minimize the number of disk accesses, that is what we can equate to efficient search. Consequently, a B tree is an ideal data structure for situations where all data cannot reside in primary storage and accesses to secondary storage are comparatively expensive or time consuming. So definitely D is also true. If you take database management system, file organization topic, you can even find B tree content there. From this we can understand all the 4 statements are true, but at most we can find only A, B and D are given right here in 4th option. So this question has been officially dropped. It means there is no answer key provided. So if you want to get the answer, it will be option A, B, C, D. All the 4 statements are true. Next question, which of the following is not a divide and conquer method? So this is also one of the previous year questions. Sometimes the previous year question can have which is a method and sometimes it can be taken as which is not a method. So once you understand what are the applications of divide and conquer method, you should be able to answer which applications are not following this particular method. So let's see the divide and conquer applications. We have binary search, merge sort and quick sort, median finding, minimum and maximum finding, matrix multiplication and closest pair problem. We have binary search here, we have merge sort and quick sort. Heap sort is not available in this list, so we go with option number 4, heap sort as the right answer. This is not a divide and conquer method. Next question, which of the following uses only increment operations for adding and removing element at either end? Either end means when you take stack there is only one end. When you take queue there are 2 ends, front and rear. Similarly, when you take priority queue or DQ, there are actually 2 ends. So based on either end, we can say stack is definitely not a part of the solution. Now we will understand about every option. Queues follow first in first out, FIFO principle. Add elements at the rear end and remove elements from the front is what we can say. So this is not allowing at either ends. So queue is also ruled out from the answer list. Let's see about stacks. Stacks follow the last in first out LIFO principle. Add and remove elements at one end, that is the top of the stack. We have already ruled out stacks. What about priority queues? Priority queues are not concerned with the order of insertion but rather with the priority of the elements. The element with the highest priority is removed first. So it is not about any end, it's just about the priority. So definitely 3 is also not the answer here. What about D queues? A D queue allows for insertion and deletion of elements at both ends of the data structure. This can be equated to either end, that is at both the front and the rear. This means you can efficiently add or remove elements from either end using only increment or decrement operations for the pointers that indicate the positions of the front and rear ends. So this particular statement is equating to the question statement, and so we are going with option number 4, DQs as the right answer. As a learning part, what you can do is you can see how queues are implemented, stacks are implemented, priority queues and dequeues are implemented. Just learn along with diagrams, understand how insertion deletions are happening so that it might be useful for you in some other question paper. Next question, considering the above binary tree, what will be the in-order traversal? What are the steps for in-order traversal? Visit all the nodes in the left subtree, visit the root node, visit all the nodes in the right subtree. So we'll start with left subtree. We don't have any left or right here, so we are selecting B first. So let's take this as right and this as left. This is root. So now left is done. What about the second step? We have to visit the root node. So we are considering A here. So this is also done. Now come to the right side. You have to move to the left side first. So when you go this way, this is left and this is right. So you have to pick the left element here, which is D. So D will be here. Then you have to pick up the root for this particular left and right. So this is C. Now again get to the right side. For this particular subtree, you don't have left here, but you have the root node. So you have to include E here. This is actually the right side of the E node. So for right subtree, again you have to go with left, right, root. So what is left here? It is G. What is root? It is F. What is the right? It is H. This is how you have to do in-order traversal. B, A, D, C, E, G, F, H. This is available in option number 1. If you are not able to traverse in the same diagram, just take A, B, C. This is left, this is right, and this is the root node you can take. You go with B, A. For C, what you can do? You can take C here and go with D and E separately. Take only D and C, cut off E from here. Take the E subtree separately. E, F, it is given here. So here you have no left and only the root is there. So mention the root. After the root only you are going to process the right side. So cut this part. Again go for F. F has a left child and a right child. What is the in-order traversal? It is G, F, H. So this order will be given as it is. This is how you have to split and do for a big tree. Let's see the other options. G, H, F. So they are starting with this particular tree. Actually we have to not get inside the right part. So option 2 can be ruled out. If you take B, A and C, they have started with left, root and right. This might be correct if C does not have any child. But C has left and right children. So definitely this order cannot be taken. So 3 is also ruled out. Again it is starting with G, H, F. So we can rule out. Next question. Which of the following is the solution of the following recurrence relation? So we have already solved few recurrence relations in the previous year question paper. We will take the Master's theorem. This particular Master's theorem is in the form of T of n is equal to A into T n by B plus F of n, and this Master's theorem is in the form of C into n power D in the place of F of n. So you can either refer to this Master's theorem or this Master's theorem, but here it is given in the form of big O only, but here it is with respect to big O, theta and omega. The Master theorem states that for a recurrence of the form T of n is equal to A into T n by B plus F of n. The number of subproblems is denoted by A and the factor by which the problem size is divided is given by B. What about F of n that comes outside here? This is the work done outside the recursive calls. So whatever happens in between A into T of n by B is about recursion, and whatever is given along with the recursive call is the work that is done outside the recursive calls. Let's take the given recurrence relation T of 2 into n by 3 plus 1. Do we have any A term here? A can be equated to 1 because 1 into something is going to give that something only. What about the B value? In the general form, it is given as T of n by B. B is given in the denominator. When you have a fraction in the denominator of the fraction will go to the numerator. Say for example, if you have n divided by 3 by 2, this can be written as 2 into n by 3. So you have to understand this form is rewritten in this way. So what is B here? It is 3 divided by 2 and not 2 divided by 3. So we have A is equal to 1 and B is equal to 3 divided by 2. So what is n power d here? It is given as 1. Say for example, n power 0 can be taken as 1. This n power d can be equated to n power 0, which is equal to 1. This is the f of n part as per this particular formula. So here we can equate d is equal to 0. Now we have to check a and b power d. A is equal to 1. What is b power d? This is also equal to 1. From this what we can understand, a is equal to b power d. So we are going with the second part. So this is giving big O of n power d log n. What is n power d? It is n power 0. What is log n? We have it as it is. So what is n power 0? It is 1. 1 into log n will give you big O of log n. So here they have given with respect to big O, but here it is given in form of theta. I will tell you how it is equated. So right now we have to understand log n is the complexity. So we will go with option number 2 as the right answer. Now let me solve with this particular part. We can interpret n by b to mean either n divided by b under floor or n divided by b under seal. Then T of n has the following asymptotic bounds. They have given theta everywhere, so we will pick up this one. So we will go with theta of n log ba. So this particular part is taken to be 0. Only n power 0 will give you 1 in this particular place. From this we can infer log a to the base b is equal to 0. Now just apply here. This is theta of n log ba log n. This is T of n is equal to. So from this theta of what is log a to the base b? It is n power 0 log n. From this we can say it is theta of log n. So we are going with option 2 as the right answer. So whether you take it this way or this way, you should be able to apply the power and get it properly. Next question. Arrange the following steps of the in-order traversal of binary tree in the correct order. Visit the left subtree, visit the root node, visit the right subtree. Start traversing by visiting the nodes in rooted tree. Repeat the above 3 steps. They have given the clue here, start traversing. So we have to start with D. We can rule out option 1 and 2. Then we have to get into the traversal. Left, root and right. So A, B, C. A, B, C is given here. So we can rule out even option 4. What about E? Repeat the above 3 steps. So if you take B, then A, then C, here you can stop within these 3 nodes. But when you have subtree here, you have to go for repeat. So we are starting, going for the traversal and then repeating the process again. D, A, B, C, E is available in option 3. Option 3 will be the right answer. Next question. Which of the following algorithms are based on the breadth first search? When you take breadth first search application, Dijkstra's algorithm will have a direct application. Dijkstra's algorithm is a generalization of the breadth first search algorithm. This point is actually given in many of the books. So we know definitely C is in the answer. Any option that does not include C can be ruled out. So from this we can say Kruskal is not there and dynamic programming is also not there. Dijkstra's algorithm uses a priority queue to efficiently find the shortest path from the source vertex to all other vertices in a weighted graph. It can be thought of as a weighted version of BFS. So this is definitely there and this is C. What about Prim's algorithm? In Prim's algorithm, priority queue is used to efficiently select the edge with the smallest weight that connects a vertex in the minimum spanning tree to a vertex outside the minimum spanning tree. It is somewhat similar to how BFS explores the nearest nodes first. Prim's algorithm does not have a direct application of BFS, but they say the way it selects the edges is similar to how BFS explores the nearest nodes first. So this can also be included. So A is definitely there. Now we have to check whether D is included or not. Greedy algorithm. This approach makes a series of choices by picking the best available option at every step, aiming to find a local optimum with the hope of finding a global optimum. Prim's algorithm and Dijkstra's algorithm, they use a priority queue to start with a shortest path in case of Dijkstra's and to select the edge with the smallest weight in case of Prim. But in greedy algorithm, we are not going with such criteria. Instead, we are just taking the best one available at every step. So in that way, greedy is not connected to Dijkstra's and Prim's. So we are removing even greedy algorithms from the answer list. So 2 is also ruled out. Option number 4, A and C only will be the right answer. What about dynamic programming? A method for solving complex problems by breaking them down into simpler subproblems and storing the results of subproblems to avoid redundant computations. This is nowhere related to BFS, so we are ruling out dynamic programming. What about Kruskal's algorithm? This algorithm follows a greedy strategy through its approach of always picking the smallest edge that does not form a cycle. So Kruskal algorithm is also to find minimum spanning tree. But how does it pick? It will pick the best available option at every step. What is best available option? Whichever edge that is smaller and that does not contribute to a cycle will be picked up. So this is following greedy strategy. Next question, choose the correct statements. A problem which is NP complete will have the property that it can be solved in polynomial time if and only if all other NP complete problems can also be solved in polynomial time. All NP complete problems are NP hard problems. If an NP hard problem can be solved in polynomial time, then all NP complete problem can be solved in polynomial time. All NP hard problems are not NP complete. This is the diagram that we know about NP, NP hard and NP complete. From this diagram, what you can understand is NP complete problem is an intersection of NP and NP hard. NP hard does not have a closed bound. It is open. Just check this statement. All NP hard problems are not NP complete is perfectly true. Just take for an example, NP complete has a count of 10 problems. Since NP hard is given in open end, it will have some 20 or 30 problems, but definitely more than 10. So they are saying all 30 problems are not NP complete problems, which is perfectly true. So D is definitely true. All NP complete problem are NP hard problems is what B statement is telling. If you take this particular 10 problem, it is a part of NP complete. At the same time, it is a part of NP hard problem too. So all NP complete problem are definitely NP hard problems because NP complete is intersection of NP and NP hard. So B is also right. NP complete problems are a subset of NP hard problems that are both in NP and NP hard. Not all NP hard problems are NP complete. This point is what they have rewritten in statement D. All NP hard are not NP complete is equal to not all NP hard are NP complete. So both are same. Any NP complete problem can be reduced to any other NP complete problem in polynomial time. If one NP complete problem can be solved in polynomial time, all NP complete problems can be solved in polynomial time due to this polynomial time reduction property. A problem which is NP complete will have the property that it can be solved in polynomial time if and only if all other NP complete problems can also be solved in polynomial time is what this statement is also saying. So A is also true. This particular statement will state that both B and D are true. Similarly, this particular point will state that A is true. If an NP-hard problem can be solved in polynomial time, it implies that there is a polynomial time algorithm for the hardest problems in NP. Just check with C. If an NP-hard problem can be solved in polynomial time, then all NP complete problem can be solved in polynomial time. So the subset of NP hard is NP complete. So definitely C is also right. You can take these 2 points into consideration to say C is true. So we know NP complete is a subset of NP hard. When you have an algorithm to solve them, definitely this can also be solved in polynomial time. All the 4 statements are true. So we are going with option number 4, A, B, C, D as the right answer. Next question. Match the list 1 with list 2. List 1 has search and sort algorithm. List 2 has complexity. Let's start with binary search. A search algorithm that finds the position of a target value within a sorted array by repeatedly dividing the search interval in half. If there are going to be n elements, you are going to consider only n by 2 elements at a time, which is going to have the complexity of big O of log n. B will be mapping to 1. B1 is available only in one option. We will go with option number 1 as the right answer. What about insertion sort? This is a simple sorting algorithm that builds the final sorted array one item at a time by repeatedly taking the next item and inserting it into its correct position. The time complexity is given as big O of n square on average and worst case, and big O of n in the best case when the array is already sorted. Quick sort. A highly efficient sorting algorithm that uses a divide and conquer approach to partition the array into subarrays which are then sorted independently. The time complexity will be big O of n log n on average, but big O of n square in the worst case when the pivot is poorly chosen. We usually choose the leftmost element as the pivot element, but here they say when the pivot element is poorly chosen, it can result in big O of n square in the worst case. Otherwise, this has a complexity of big O of n log n. What about selection sort? A simple comparison based sorting algorithm that repeatedly selects the smallest or largest element from the unsorted portion of the array and moves it to the beginning or end. So if it is smallest, it will be moved to the beginning. When you choose the largest, it moves to the end. You have to apply it in this way. The time complexity is big O of n square in all cases. So D will be mapping to 2 in all cases. What about quick sort? We have n log n. So C will be mapping to 4. What about A3? So just take this to be big O of n. So A will be mapping to 3 here. A3, B1, C4, D2 will be the right answer. Next question. Match the list 1 with list 2. We have breadth first search, depth first search, prefix, infix in list 1. Lisp, it's a programming language. Syntax tree, stack and queue in list 2. BFS uses a queue to keep track of the nodes to be explored. It explores all nodes at the present depth level before moving on to nodes at the next level. So BFS is going to use queue. A will be mapping to 4. What about DFS? Depth first search can be implemented using a stack, either explicitly with a stack data structure or implicitly with the call stack during recursion. It explores as far down a branch as possible before backtracking. B is mapping to 3. A4B3 is available only in one option. We can rule out the other 3 options. Option number 4 will be the right answer. Prefix notation, which is also called as polish notation, is commonly used in list processing, which is a programming language. What about infix? Infix notation can be represented using a syntax tree, which is a hierarchical structure that represents the syntactic structure of expressions based on grammar rules. This is postfix and this is prefix. What is infix? It is A plus B. Prefix C will be mapping to one Lisp and D infix is mapping to 2 syntax tree. A4, B3, C1, D2 will be the right answer. With this, we are completing Unit 7 solutions. Let's solve Unit 8 Theory of Computation and Compilers questions. Which of the following is true about the pumping lemma for regular language? When we say it's a pumping lemma for regular language, it applies to all context-free languages will be ruled out, because there is a pumping lemma for context-free languages. Here for regular language you will be splitting the string into 3 strings, but in pumping lemma for CFL you have to split the string as 5 strings. And when this is a pumping lemma for regular language, definitely it will not apply to recursively enumerable languages. So we can even rule out option 4. Now it's between option 1 and 2. The pumping lemma states that for any regular language L, any regular language means it applies to all regular languages. Based on this particular statement, we can mark option number 1 to be the right answer. Now let's see the pumping lemma definition. There exists a constant P, which is the pumping length, such that any string S in L with a length of at least P can be divided into 3 parts. S is equal to X, Y, Z, satisfying the following conditions. So here the division is into 3 parts. But in CFL pumping lemma, you will be dividing it into 5 parts. So that is the difference there, and the conditions will also change based on those parts. For each I is greater than or equal to 0, X, Y power I, Z is in L. So when I is equal to 0, even when the Y part of the string is missing, X, Z should be there in the language. Length of Y is greater than 0. This states that the string Y should not be empty. The length of XY should be less than or equal to P. This P is nothing but the pumping length. So if all these 3 conditions are satisfied, then we can say that language is regular language. Whenever you take any language, there will be finite language and infinite language. In regular language, we say finite when we are able to produce all the strings of the language. Based on all the strings, we can say whether one string is existing in the language or not. But what about infinite regular languages? We will not know all the strings that belong to the language. Pumping lemma is actually used to check whether a language is regular or not in the case of infinite languages only. The application is mainly done for infinite regular languages. There are books which suggest that pumping lemma for regular language can be applied only to infinite language, because in finite cases we need not use pumping lemma is what they say. Next question. Which of the following represents the output of the transition function? Based on the option, you can understand it is A power n, B power n string. And usually we use push down automata to implement this particular string. Now we have to find what mission is this. This is actually Turing mission. When we have a transition del current state comma current symbol being read, so there are 2 parameters in del here. What happens in the transition is next state, symbol to be written, direction to move the tape head is given. In push down automata you have stack operation, but here when you have something called direction to move the tape head, you should understand that Turing mission is used here. So let's look at the option now. L is equal to A parent, B parent. They have given 4 conditions. The first condition is n is greater than or equal to 0, which means the n value will be starting from 0 and it goes on. What about the second option? They have given n greater than or equal to 1. So n value will be starting from 1 and it goes on. What about the third option? N greater than 0. This is also having the same set of values similar to option 2. What about fourth option? N greater than 1. Here the starting value of n will be from 2. It will not include 0 and 1. So basically we have to see when n is equal to 0, what happens? You will have empty string. Do you have any transition which has empty string operation? You have the initial state as Q0 here and the final state as QF. And here is something, a symbol like square. What is this square called? It's actually the blank symbol. Whenever you have a Turing machine, a blank will be denoted as the last character to say that you have reached the end of the string. That is, all the input characters or all the input symbols have been processed and you have come to the end. That is where we make use of blank to say that you have reached the end of the process. So from Q0, do we have any transition to process empty string? We have only one transition function Q0 comma A. So except for input A, we don't have any other transition starting with Q0 here. And similarly, we have something called Q0 comma Y. So Y is a part of the process. We will see that later. There is no transition that will process empty string. So we can rule out option 1 even before starting the work. Now let's take n is equal to 1. When n is equal to 1, we will have a power 1 b power 1 which is equal to ab. When n is equal to 2, a square and b square which can be represented as bb. So let's start with the first transition. So let's take this one. Del Q0 comma A is equal to Q1 comma X comma R. This indicates that the machine starts with an A, marks it as X and moves to the right, transitioning to state Q1. Initially this is in Q0 state along with the blank symbol. Now this A is marked as X. And what is the current state now? It is Q1. So now it will be X, B along with blank. Where is the tape head moving now? To the right direction. Here is the tape head now. How do you read this particular transition? You have to read this as Q1 comma B. So go for Q1 comma B. It is here. What happens in Q1 comma B? This marks the first B it encounters, moves to the left and transitions to state Q2. So this B is now changed as Y as we see here. It is the symbol to be written. So we are marking the first B as Y and then we are moving to state Q2. So now we will have Q2 and the direction of head movement will be left. So we have X here. Now we are moving to this X. What is the next transition that we have to check? Q2 comma X. Where is Q2 comma X? It is here. What is the transition telling? You have to go to state Q0. You are not marking anything there. X is staying as it is. So we are moving to state Q0 here. And then we are moving to right means we are in Y. So do we have any transition Q0 comma Y? We have here. This Q2 comma X returns the machine to state Q0, continuing the process until all A's and B's are matched. What about Q0 comma Y? From here, transitions indicate the machine is moving towards the final state after all A's and B's have been processed. Now what we have to do is, we have to go to Q3 state. There is no marking of symbol, it is already Y. And it is asking us to move towards right. So if you move towards right, what symbol is here? It is the blank symbol. So now we are moving to this particular blank symbol. What is the new transition now? Q3 comma blank symbol. Do we have any transition here? Yes. Q3 comma blank symbol will say you have reached the final state. So once you reach the final state, it means the string is accepted and you can understand the process has been successfully completed. When n is equal to 1, the language has the string AB and this is successfully processed by the Turing machine. Now let's take the next string. Where n is equal to 2, we will have AABB. So initially we will start with Q0. What is Q0 comma A? We are moving to Q1, marking this A to be X, and we are moving to the right. So here we are changing this as Q1, we are marking this as X, and we are moving to the next A. This is the right movement. Do we have any transition Q1 comma A? Yes, we have. Let's take this particular transition. This allows the machine to continue reading as while moving to the right. So when you have other A's, it will just keep moving right. For first A, it will change the first B. And for the second A, it will change the second B. When you are taking one A for one B, what you can understand is you can check number of A's are equal to number of B's. When A is greater than B or when B is greater than A, there will be a problem in this particular matching. So based on that, we can understand that the string is not present in the language. So now we are in this particular transition Q1 comma A. What is happening here? You are still in Q1, but you are just moving to the right. So now we will just move to the right. We are in B. What about Q1 comma B? Q1 comma B we have already seen here. We are going to state Q2, marking it as Y. So we have X here, A here, this is changed as Y and the movement of the head will be towards the left. Now we are in state Q2. Do we have transition for Q2 comma A? Yes, we have here. Q2 comma A will be Q2 comma A along with left direction. So there is no change in the state. There is no marking, but you are just moving to this particular X. So now the transition will be Q2 comma X. Do we have Q2 comma X? Yes, we have already seen that. We are moving to state Q0 and we are moving towards the right. So here we are moving to state Q0 and we are moving towards the right. In the right, what symbol you have? You have A here. So you have X here, you have Y here, you have B here and finally you have the blank symbol. I will also place the blank symbol here. Now we are in A. So again we are getting into Q0 comma A, which is the first transition. What happens? Q1 comma X to the right. So it is Q1. We are changing this as X and we are moving to the right. So what is here? Y is here. So Q1 comma Y. Do we have such transition here? Yes, it is here. It is not Y1, it is Q1 comma Y. What happens when state Q1 has Y here? It will just keep moving right. So here we have this X, here we have Y, here we have B. This particular transition just makes a movement to the next symbol. So what is the symbol here? It is B. Q1 comma B. We have already seen this transition. Q1 comma B will now transition to Q2 state, marking it as Y. So we will mark this as Y and we are moving to Q2 state. Now the head is moving towards the left. Left means you already have Y here. So we are getting back to this particular Y. We are in Q2 state and the symbol is Y. Do we have any transition for Q2 comma Y? Yes, it is there. Q2 transitions allow the machines to move back to the beginning of the string and look for the next unmatched A marked as X. So now we are again moving back to the left. So from here we are moving here to this particular X. What is this transition now? Q2 comma X. Do we have Q2 comma X? Yes, we have already seen it. Now we are changing to Q0 state here and we have to move towards the right. So taking this to be Q0 comma X, we are just moving towards the right. So now the transition will be Q0 comma Y. Do we have Q0 comma Y? Yes, it is here. Now we are moving to Q3 comma Y and we have to move in the right direction. So let's move to the right direction. Now the state will be Q3 comma Y. What transition is there in Q3 comma Y? This one. The state is Q3. There is no change to the Y symbol here and we are still moving to the right. We are already in the last symbol. So what is here after the last symbol? We have the blank symbol. So now we are moving towards this particular blank symbol in Q3 comma Y transition. Now we have Q3 state along with blank as the symbol. What is Q3 comma blank? We are here and so we have reached the final state ultimately. So it is also processing AABB string. Regarding option 2, AB is also processed, AABB is also processed correctly. Option number 2 will be the right answer and it is the official answer key that is provided. Let's go for option 3. What is n greater than 0? N greater than 0 is equivalent to n greater than or equal to 1. When you have n greater than 0, n's value will start from 1 and it goes on. When you have n greater than or equal to 1, there also n starts from 1 and it goes on like this. So they have typically taken this condition as the official answer key. But n greater than 0 is also right with respect to this particular language a power n, b power n. So I cannot rule out this option, but this can also be included in my opinion. So we are ruling out 1, but we are including 3 also as a possibility here. What about the fourth one? This condition here states that n will be greater than 1 where n is equal to 1 is excluded. This particular transition function is processing the string AB where n is equal to 1. This is excluded by option 4 because it is starting from AABB only. AABB is successfully processed, there is no doubt. But this language should include AB, which will not happen because n's value is greater than 1. So we can rule out fourth option also. Definitely 1 is not there, 4 is not there. We are going with option 2 as the right answer. But in my opinion, both these languages are same. This transition working will be effective only when you work it on your own instead of watching only in videos. Next question. YACC is which of the following parsers? YACC stands for yet another compiler. So this belongs to LALR parser. Option number 4 will be the right answer. I'll just give you a depiction here. This is how we create an input-output translator with YACC. So YACC specification is given with .y file. It passes through YACC compiler and it changes to .c file. This .c file is passed through C compiler and we get .out file. When inputs are supplied from the user, this file gets executed and then the output is given. This input is given by the user and this output is what we see in the screen. Next question. Regarding the code optimization, choose the correct sequence. Algebraic simplification, use of mission idioms, redundant instruction elimination, flow of control optimization, improve target code. First we will understand what are these 5 statements. After understanding them, we will choose the correct sequence. Let's start with algebraic simplification. Simplifying algebraic expressions to reduce the complexity of computations. What does this include? Constant folding, strength reduction and simplifying expressions. What about use of mission idioms? Replacing general code patterns with mission specific instructions or idioms that are more efficient. This step is architecture specific and involves using instructions that are optimized for the target mission. What is redundant instruction elimination? This is removing unnecessary instructions that do not affect the program's outcome. This helps in reducing the code size and improving execution time. Common techniques include dead code elimination and common sub-expression elimination. If you want to know more about these terms, you can always refer to the reference book. Right now I am just giving you the techniques that are used here. What about flow of control optimization? This is improving the flow of control in the code to make it more efficient. This includes techniques like loop unrolling, loop fusion and branch prediction. What is improved target code? Generating the final optimized mission code or target code that is ready for execution. This step involves register allocation, instruction scheduling and other low-level optimizations specific to the target architecture. Now, taking all these 5 steps, let's look at it in a general angle. Here we have something called final optimized mission code. So when you do code optimization process, finally you will have some output. That output is the target code that is ready for execution in the compiler phase. So E will definitely be the last step. Here you can find all the options are having E as the final step. Now we will check with A, B, C, D. You are going to simplify some expression, you are going to replace some pattern, you are going to remove some unnecessary instruction reducing the code size and you are going to improve the flow of control. Actually, when you get 100 lines of code, you have to remove all the unnecessary instructions and you can reduce it to 80 lines of code. So reduction of code can happen in the first place. C will happen first in the sequence. So the sequence starts with C and ends with E. The only option that starts with C is option number 3. So we can go with option number 3 as the right answer. So redundant instruction elimination will be the first in the sequence. After that, you can optimize the flow of control. It means you can work with the loops and branches. So definitely C will be followed by D. The next work that you can do is simplify algebraic expression. Why do we actually simplify? To reduce the complexity of computation. So the next step will be A. We can replace general code patterns with mission specific instructions. Actually B is going more target mission oriented and E is perfectly done for the target mission. If you find that the fourth step is going to be B, even here you have only one option with B in the fourth step. Just by reading the instruction, you can find this order initially and C to be the first one. So replacing general code pattern will be followed by step A. The correct order will be C, D, A, B, E. Next question. Which of the following CFG is in Chomsky normal form? All capital letters are variables, that is non-terminals, and lowercase are terminals. What is Chomsky normal form? CNF. CFL is context-free language and CFG is context-free grammar. Every non-empty CFL without epsilon has a grammar G in which all productions are in one of two simple forms. Either A derives BC, where A, B and C are each variables, or A derives small a, where capital A is a variable and small a is a terminal. This is what they have even mentioned in the question. Now let's check A. We have S derives A, B, C or AB. This production can be written as ABC and AB. Either you can have two variables in the right hand side or one terminal in the right hand side. Here you have three variables. So this is not in Chomsky normal form. Now let's get into B. X derives RT or TR. So this can be X derives RT and X derives TR. So there are only two variables here. What about the next production? T derives small t. This is also adhering to the rule. What about R derives xt and R derives R? So R is deriving two variables here and R is deriving one terminal here. All these productions go with the rules given in Chomsky normal form. So B is definitely in Chomsky normal form. Once you find that A is not in the list, you can rule out option 1. Once you find that B is included in the answer, you can rule out option 3. Now you have to check whether D is there or not. So initially we will work with D. We have M derives Mn, M derives Mp. This is fine. What about N production? N derives Nm. This rule is saying it will have only one terminal. So this rule is actually violating CNF here. And then we have N derives N, which is okay, and P derives P is also okay. But this one is violating it. So D is not in the answer list. So from this you can also rule out option 4. Option number 2, B only will be the right answer. Now let's see what is wrong with C. P derives terminal non-terminal. P derives terminal non-terminal. Q derives terminal, Q derives terminal. This is fine, but both these forms are wrong. This is perfectly wrong because they have told it should end up with 2 variables in the right side or 1 terminal in the right side. So this is also not in CNF. Next question. Match the list 1 with list 2. So we will see the Chomsky hierarchy now. Type 3 is regular grammar, that is accepted by finite automata. Type 2 is context-free grammar accepted by push-down automata. Type 1 is context-sensitive grammar accepted by linear-bound automata. And type 0 is unrestricted grammar recognized by Turing machine. Recursively enumerable grammars generate all possible languages that can be recognized by a Turing machine. They have no restrictions on the form of their production rules. So recursively enumerable grammar will be type 0. A will be mapping to 4. The only option that maps A to 4 will be 4th option. So from this you can rule out the other 3. What about type 1 grammar? It is context sensitive grammar. One example is given in list 2 here. X derives Y. Length of X is less than length of Y, where X and Y belong to variables and terminals together. This belongs to context sensitive grammars where the length of left hand side of a production rule must be less than or equal to the length of the right hand side. B is mapping to 3. What about type 2? Type 2 grammar is context free grammar. Context free grammar can be expressed in Chomsky normal form as we saw in the earlier question and Greback normal form. A Greback normal form grammar is a normal form for context-free grammars. GNF is useful for converting CFG into a form that can be recognized by push-down automata. And regarding linear grammar, this is a type of context-free grammar where each production rule has at most one non-terminal on the right-hand side. We are mapping C to 1. Greback normal form production rule will be A derives A alpha. Small a is a terminal followed by one or more variables is what we mention here as alpha. Somewhere they say this particular production rule structure is given by right linear grammar which is falling under regular language. So taking that point into consideration, we are mapping D to 2. A4, B3, C1, D2. Option number 4 will be the right answer. But if you take type 3 grammar, none of the options in list 2 are type 3 here. And whenever you take this particular hierarchy, whatever language is recognized here, that will be recognized by type 2 languages. So taking that into consideration also, you can map D to 2. Next question, match the list 1 with list 2. Conflict resolution in parsing often involves precedence rules to determine the order of operations. So we can map A to 2. A2 is available in 2 of the options. What about common subsequence? Finding common subsequences is related to optimization problems often visualized using direct acyclic graphs, that is DAGs. So we can map B to 4. B4 is available here, so we can rule out the other 3 options. Quadruples are a form of intermediate code representation used in 3 address code. So C will be mapping to 1. L attributed definitions are a type of syntax directed translation used in compiler design. So D will be mapping to 3. A2, B4, C1, D3. Option number 2 will be the right answer. Next question. From here we have a set of 5 questions. A machine is represented by states capital Q, input alphabet, transition function, initial state Q0 and final state F. The machine accepts all the strings over A, B, which start and ended with any combination of all alphabets, and A, B works or lies as substring in all the strings to be accepted. It can either start with A or B, and it can have any number of A's and B's. Similarly, it can have any number of A's and B's. But in between you should have the substring ABB is what this particular paragraph is telling us. Let's start working with the first question. For the above specified passage, which of the following represents the regular expression? A plus B means A or B. So let's start with A. What is closure symbol? It means zero occurrence can also be considered. Zero occurrence means sometimes this particular term can be totally eradicated. So we can have A as the starting, B as the starting and nothing as the starting, followed by AAB, followed by AAB, then only AAB can be taken. Are these 3 strings having ABB in between? No. So definitely 1 is not the answer. What about ABA? This will have a fixed string ABA and any combination of A and B can occur here. Closure is given, so definitely this will be the minimum string that is available for this language. So this expression is also not the right answer. What about this particular expression? Take out all the closure expression and only pick this alphabet here. We have B, B, A definitely, even when clean closure completely gives empty. BBA pattern is not mentioned in the passage. So 3 is also not in the answer. Here we have the string ABB. They say ABB works or lies as substring. So when this clean closure has 0 occurrence, the minimum string will be ABB. Before ABB, in the starting, it will have any combination of all alphabets is what we can take it as A or B, the clean closure that comes in the starting as well as that comes in the ending. So this is any combination of A or B that we saw here in this particular format. So option number 4 will be the correct regular expression which represents the machine that is specified in the passage. Option number 4 will be the right answer. Next question. For the above specified passage, which of the following represent the grammar for the language accepted by the machine? So let's take the first option. S derives A, B, B. What does this production rule of A say? It has only A terminal along with epsilon. So this will have only A's and this B will have only B's. So it will start with A's, have the string ABB and then end with B's. What is the passage actually telling us? It should start and end with any combination of all alphabets. So the first option has an optional sequence of A's followed by the fixed string ABB followed by optional sequence of B's, which is not the one given in the passage. So 1 is ruled out. What about the second one? We have ABB string and then capital A. This A variable production will have A or B or epsilon. This actually satisfies the combination of all alphabet condition, but it is given only in the ending. What about the starting? We don't have anything. A fixed substring ABB followed by any combinations of A's and B's including none. So this is not talking about the starting and ending but only about the ending combination. So 2 is also ruled out. What about 3 here? We have A, B, B, then A. What is this A representing? It has A, it has B, it has epsilon. What about this A then? The same set of productions apply here also. So this represents the combination of all alphabet and this represents the combination of all alphabet along with the substring ABB here. So even when this A does not derive anything, ABB stands as it is. So the grammar given in option 3 is actually representing the grammar for the language given in the passage. Any combinations of A's and B's followed by the substring ABB followed by any combinations of A's and B's. This is perfectly matching. So we can go with option number 3 as the right answer. What about option 4? It's just the same as option 2 but the variable is placed in the beginning. We have A, B, B. This A can be A, B or epsilon. What about the ending? There is no specification. Any combinations of A's and B's followed by fixed substring ABB. But they have not mentioned anything about the ending. So here the starting is missing and here the ending is missing. That's why we are ruling out option 4 also. Next question. For the above mentioned passage, which of the following is correct? So we have to find the automata of the language. Now let's take the first option. We have A, B, B string here and this particular transition states that it has a combination of A and B. But there is no A and B combination in the ending part. So 1 will not be the right answer. Strings of A's and B's ending with ABB. It is not the right representation as given in the passage. What about the second one? Here we have ABB and then it ends with a combination of A and B. This will be the string of A's and B's starting with ABB. So this is also ruled out. What about third one? We have ABB here. It has A and B combination in the starting and A and B combination in the ending. So this will be strings of A's and B's in the starting and ending with ABB as substring. This is actually matching with the question and so we are going with option number 3 as the right answer. Regarding fourth one, it is starting with AB combination, then it has the string ABB. Again we are given A and B combination. But why is option 4 ruled out? Here you can find this symbol to be the starting state and this symbol to be the final state. So initial will have this particular symbol and final will have double circle on the state. So this will be final. Regarding the fourth option, the initial state is 1 and the final state is also 1. When you make 1 to be the final state, you need not go for ABB string at all. Any combination of A and B will be more than enough for this particular machine to accept the string. If I say it is AB, this will be accepted. If I say only A's, it will be accepted because they have made the initial state as the final state. So this will not work for this particular passage. Strings of A's and B's in the starting and ending with ABB as substring is fine, but this accepts empty strings without ABB also, or it will accept any string that is without ABB also. So in that case we are ruling out option 4. Next question. For the above specified passage, which of the following is DFA for the language represented or accepted by the machine? What is DFA? Deterministic finite automata. For each state and input symbol, there is exactly one transition to a next state. In NFA, there need not be only one transition, there can be more than one transition. That is the basic difference. Now let's check for option 1. From state 1, for input A, we are in 1 itself. This self loop is 1. Again from 1 for input A, we are moving to state 2. So there are 2 transitions for the state with the same input symbol. This is not a DFA. Because for input A there are 2 next states 1 and 2. Just based on this we can conclude 1 is not the answer. What about 2? From 1 for A we go to 2. From 1 for B we stay in 1. From 2 for A we are staying in 2. From 2 for B we are going to 3. From 3 for B we are going to 4. Regarding 4 we are ending up with the same state again. But does this automata represent the string that is given in the passage? We have to check that. It starts with B. There are many B's. Then we have A. Then we have many A's. Then we have BB followed by A's and B's. This is not the string that they have defined in the passage. So 2 is also ruled out, though it is a DFA. Now let's check for the third one. From 1 for A we have 2. From 1 for B we have 1. Regarding 2, for A we have 2. For B we have 3. For 3, for A we have 2. We are just going this way back. And for B we have 4. What about 4? For A we have 5. For B we have 4. What about 5? We have A to state 5 again. Then B to state 6. What about 6? For A we have 5. For B we have 4. Definitely this is a DFA. Let's check whether it is accepting the string given in the passage. This particular part is having combination of A's and B's together. 3 to 2, 2 to 3, 3 to 4 can give ABB, or 2 to 2, 2 to 3 and 3 to 4 will also give ABB. 4, 5, 6 will be any number of B's and A's together. Strings of A's and B's in the starting and in the ending with ABB as substring. This one is a DFA, as well as it is accepting the strings given in the passage. Let's check the fourth one. From 1 we have A and B transition. From 2 we have A and B transition. From 3 we have A and B transition. From 4 A and B. From 5 we have A and B. From 6 we have only B. So now we have to check for ABB string pattern. String of A's followed by B in the starting, followed by ABB string. Again we have string of B's in the ending. If you take this particular part, you will have strings of A's, but only one B is given in the transition here. So here it is string of B's and here it is string of A's. But the combination should have A's and B's together. So 4 is also ruled out. So option number 3 will be the right answer. This is the DFA for the language represented by the mission given in the passage. The final question. Which of the following represented the minimum state DFA for the above specified passage? This is the DFA that we have got from the previous question. What is minimal state DFA? It has the smallest possible number of states while still recognizing the same language as the original DFA. So the original DFA had 6 states. Minimal state DFA will have smallest possible number of states. So based on this particular DFA, we have to make sure there are reduced number of states. First let's check option 1. From 1 you have 2 transitions with input symbol A. This is not a DFA. In state 1 there are 2 transitions for A. Only when it is a DFA we can check whether it is minimum state DFA. So option 1 is ruled out. What about option 2? This state 2 has 2 transitions for the same input symbol A. This is also not a DFA. In state 2 there are 2 transitions for A. So we will even rule out option 2. What about option 3? For 6 you have 2 transitions with A here. This is not a DFA. In state 6 there are 2 transitions for A. So we can rule out even option 3. What about option 4? Here also this is violating the DFA rule for the same input symbol. This is also not a DFA. In state 1 there are 2 transitions for A. So we are ruling out even option 4. All the representations given here are NFA. Only when it is a DFA we can check whether it is minimal state or not. Since none of the options are correct, this question has been dropped in the official answer key. With this we are completing Unit 8 solutions. Let's solve Unit 9 Data Communication and Computer Networks questions. Arrange the following steps of the DHCP, Dynamic Host Control Protocol, process in the correct sequence. DHCP provides static and dynamic address allocation that can be manual or automatic. And let's see the process now. The first step is DHCP discover. The client device sends out a broadcast message to locate available DHCP servers on the network. Next is DHCP offer. DHCP servers on the network responds to the DHCP discover message with the DHCP offer, which includes an available IP address and other configuration information. The next step is DHCP request. The client chooses one of the DHCP offers if multiple are received and responds with the DHCP request message indicating its acceptance of the offered IP address and other configuration settings. DHCP acknowledgement ACK. The DHCP server acknowledges the client's DHCP request with the DHCP ACK message confirming the lease of the IP address and providing any additional network configuration information. Client receives IP configuration. With the confirmation from the DHCP server, the client now has a valid IP address and network configuration, allowing it to communicate on the network. So what is the first step? Discover, it is B. The next step is offer, it is C. The next step is request, it is D. Then the next step is DHCP ACK. Actually it is given together, it is DHCP and ACK. This will be A and client receives IP configuration will be E. The order will be B, C, D, A, E. Option number 2 will be the right answer. Next question. Consider the following statements regarding multiple access techniques and identify the correct ones. Aloha is used for multiple access on a shared medium. TDMA uses Walsh tables for time slot allocation. CSMA CD was invented for wireless networks. CDMA codes are sequence of number generated by orthogonal codes. Let's see the statements one by one. Aloha, the earliest random access method, was designed for a radio wireless LAN, but it can be used on any shared medium. So A statement is definitely true. When A is true, you can rule out option 2 and 3. What about TDMA? TDMA allocates different time slots to different users or channels on the same frequency band. Walsh tables are actually used in code division multiple access. This particular CDMA systems actually use Walsh tables where orthogonal Walsh codes are employed to distinguish between different user signals on the same frequency. So TDMA does not use Walsh tables. B is wrong. When you know B is wrong, we know option 1 is wrong. From this we can understand D is definitely correct because this point also supports orthogonal codes statement in D. What about carrier sense multiple access with collision detection? This was actually developed for wired Ethernet networks and not for wireless networks. So this is also wrong. What about collision avoidance? This is designed to prevent data collisions in wireless networks. This wireless networks is for CSMA CA and not for CD. What about CDMA codes? This statement is right. CDMA codes are sequence of number generated by orthogonal codes. So that point is actually present in this particular statement. So we are going with option number 4, A and D only as the right answer. If you say TDMA does not use Walsh tables, then you have to know which systems use Walsh tables. So it is done by CDMA systems. When you know collision detection is not for wireless networks, then you have to know collision avoidance is for wireless networks. Next question, the Hamming distance between 10101 and 11110 is, what is Hamming distance? It is the number of positions at which the corresponding bits are different. So we have taken the first code here 10101 and the second code 11110. We have 1 and 1 here, but we have 0 and 1 here. This bit is differing. 1 and 1 is fine. 0 and 1, 1 and 0. So how many positions are differing in their bits? 3 positions. So the Hamming distance value will be option number 2, 3. So there are 3 number of positions at which the corresponding bits are different. Next question, consider a noiseless channel with a bandwidth of 5000 Hz transmitting a signal with 2 signal levels. The maximum bitrate is. For a noiseless channel, the Nyquist bitrate formula defines the maximum bitrate. Bitrate is given by 2 into bandwidth into log to the base 2 with L. This L is nothing but signal level. So according to the question, capital L's value will be 2 because they have given 2 signal levels. The bandwidth value is given as 5000 Hz. We have a log calculation here. So let's take log to the base 2 with L. This will be log 2 to the base 2. What is log 2 to the base 2? It is 1. So this can be taken as 2 into bandwidth into 1. 2 into bandwidth will be 2 into 5000 and bit rate will always be given as bits per second. So here this is 2 into 5 is 10, then we have 3 zeros. So it is 10,000 bits per second. Option number 2, 10,000 BPS will be the right answer. Next question, the primary function of firewall in network security is. The primary function of a firewall is to filter incoming and outgoing network traffic based on predetermined security rules. This is actually matching with option number 3. Option 3 will be the right answer. Firewalls act as a barrier between a trusted internal network and untrusted external networks, preventing unauthorized access while allowing legitimate traffic to pass through. Next question, the network using CSMA-CD has a bandwidth of 20 Mbps if the maximum propagation time is 25 microsecond. What is the minimum size of the frame? Minimum frame size is given by 2 into bandwidth into propagation time. We are given bandwidth and maximum propagation time details in the question. We are just going to substitute the values. 2 into bandwidth value will be 20 megabits per second. Then propagation time value will be 25 microsecond. We will have 2 into 20 as it is and we will have 25 also here. This megabits can be expressed as 10 to the power 6 bits. So this is 10 to the power 6 bits per second can be written in this way, and this microsecond can be written as 10 to the power minus 6 seconds. Second and second will get cancelled. 10 to the power 6, 10 to the power minus 6 will get cancelled. That is 10 to the power 6 minus 6 will give 10 to the power 0, which is equal to 1. This is how I am cancelling here. You have only bits unit here. 25 into 2 is 50, 50 into 20 is 1000 and the bits unit will alone stay here. Option number 2, 1000 bits will be the right answer. Next question. Sequence the following stages of the sliding window protocol for flow control. You will see the diagram of this sliding window protocol in the reference book. I have not included here in this video because it is already explained in one of the previous year question paper. I don't want to repeat that. Sender transmits frame within the window. So here it starts with sender sensor window of frames. It is B. What happens here? The sender is allowed to send a number of frames specified by the window size, but it cannot send frames beyond the window. Next one is receiver acknowledges the received frames. Receiver acknowledges the received frames will be C here. The receiver sends acknowledgement frames back to the sender for the frames it successfully receives. Sender moves the window to the next set of frames. Once the sender receives the ACK frames from the receiver, it moves the window to the next set of frames that need to be sent. So A step is here. Sender move the window to the next set of frames. What about the final step? If acknowledgement is not received, sender retransmits the frame. This is D. If the sender does not receive an acknowledgement for a particular frame within a certain time frame, it will retransmit that frame. That is what it is given as sender retransmits unacknowledged frames. It will wait for certain time and then it will retransmit. The order will be B, C, A, D. It is available in option 4. Option number 4 will be the right answer. Next question, match list 1 with list 2. Service level agreement, virtualization, Internet of Things, platform as a service. We will start with virtualization. What is virtualization? This is a method allowing multiple operating systems to run on a single physical server. B is mapping to 4. What about Internet of Things? The technology that connects and enables communication between physical devices over the internet. You can take smart home appliances under this. So if you are able to manage multiple devices with the access of your smartphone, then that can be taken as an example of IoT application. C will be mapping to 1. What about platform as a service? It's a development environment that provides over the internet to create and deploy applications. D will be mapping to 2. When you are able to work on an application directly on the internet without installing anything in your system, similar to Google Drive, that is software as a service. But if you have a development environment that allows you to create and deploy applications over the internet, that will be platform as a service. What about service level agreement? Contracts that specify performance standards and services availability. A will be mapping to 3. A3, B4, C1, D2 is available in option 2. Option number 2 will be the right answer. Next question, match the list 1 with list 2. The process or the protocols are given in list 1 and their functions are given in list 2. We have learnt about ARP, POP in previous year question papers. So let's start with Address Resolution Protocol, ARP. It's a protocol that maps IP address to MAC addresses on a local area network. B will be mapping to 3. What about Post Office Protocol? This is a protocol that allows email clients to retrieve emails from a mail server. C will be mapping to 1. B3, C1 is available only in one option. If you would have practiced previous year questions before attending this particular exam session, you could have definitely answered this question based on your learning about ARP and POP from the previous year question paper. Now let's see about Telnet. This is used for remote login to another computer over a network. D will be mapping to 2. This is not remove login, this is remote login. What about Internet Message Access Protocol, IMAP? This protocol allows accessing email on the server without downloading them. A will be mapping to 4. Option number 3, A4, B3, C1, D2 will be the right answer. Next question. Which of the following are key features of mobile ad hoc networks? MANETs. MANETs are characterized by their ability to self-organize without relying on a central authority or fixed infrastructure. Each node in the network can act as both a host and a router, dynamically establishing routes and managing network traffic based on current topology. From this we can say self-organizing and decentralized will be key feature of MANET. Definitely A is included in the answer. When A is included in the answer, C option requires fixed infrastructure for operation should be definitely ruled out, because they say it is without relying on central authority or fixed infrastructure. Again, if you take E statement, it requires a central controller to manage network traffic. So when A is right, we can remove C and E from the option automatically if you understand what is MANET. Whichever options have C and E, you can remove them. This is having E, this is having C and E, and this is having C. So only one option is left out. Nodes in a MANET are typically mobile, which means they can move freely within the network area. This high mobility allows for flexible and dynamic network configurations, making MANETs suitable for environments where network topology changes frequently, such as disaster recovery, military operations, and vehicular communication. So B statement, high mobility of nodes is a characteristic feature. Just look at this point. This is suitable for environment where network topology changes frequently, and this allows for dynamic network configuration. Based on these 2 points, we can mark D to be true. Network topology is dynamic and constantly changing. A, B and D points are key features of mobile ad hoc networks. Option number 3, A, B and D only will be the right answer. Due to the mobility of nodes, the network topology in a MANET is highly dynamic. This point is clearly supporting D. Links between nodes can be established and broken frequently as nodes move in and out of each other's range. This constant change requires robust routing protocols that can adapt to the evolving network structure. One of the defining characteristics of MANETs is the lack of dependency on fixed infrastructure and central controllers. This is the point you can find in C and E, which says they are not a feature. Instead, MANETs operate in a decentralized manner, which is supporting A, with nodes collaborating to manage network functions. Next question, choose the correct statements from the following. Let's start with A. In connection-oriented service, the destination address is to be specified only during the setup. In a connection-oriented service such as TCP, Transmission Control Protocol, the destination address is specified during the initial setup phase, which is known as the connection establishment phase. A is true. What about B? Packet sequencing is not guaranteed in connection-oriented service. This is false. Packet sequencing is guaranteed in connection-oriented services such as TCP. TCP ensures that data is delivered in the correct order by assigning a sequence number to each packet. If packets arrive out of order, TCP will reorder them based on their sequence numbers before delivering them to the application layer, maintaining the correct sequence of data. Connectionless services like UDP, User Datagram Protocol, do not guarantee packet sequencing, which means packets can arrive out of order. It is because along with each packet, UDP will carry the destination address. But here, destination address is given only in the initial setup stage. Based on this sequence number only, it has to travel to the destination is what they say. So, it is not guaranteed is a wrong point here. What about C? Flooding is method in which every incoming packet is sent out on every outgoing line except the one by which it arrived. Say for example, there are many network lines. If this line is going to bring you the incoming packet, except this line, it will send to every other outgoing line is what they say. This technique ensures that the packet reaches all nodes in the network, but it can lead to a high volume of redundant packets and can potentially cause network congestion. That's why this method is named as flooding. So C is true. Presentation layer performs detection and recovery from errors in the transmitted data. This is false. Presentation layer is available in the OSI reference model. This handles tasks such as data encryption, decryption, compression and data format translation. We know this layer is not performing this task. D is definitely wrong. Error detection and recovery from errors in transmitted data are primarily the responsibilities of the transport layer and the data link layer. The transport layer provides reliable data transfer with error detection and recovery mechanisms. What about data link layer? This handles error detection and correction for data frames transmitted over the physical layer. Here they are talking about detection and recovery, which is the transport layer part. Only A and C are right statements. So option number 3, A and C only will be the right answer. Let me again remind you, when the statement is right, you can understand more about the procedure. But when the statement is wrong, identify what is wrong in the statement. And the point that they have given here, it is not guarantee. You have to find which service is actually using no guarantee during transmission. So here we have found UDP follows this no guarantee mechanism. Similarly, we have found transport layer and data link layer are involved in error detection. But when it is detection and recovery, it is about transport layer and not about the presentation layer. And along with that, you have to also know what are the tasks that are handled by presentation layer. So you have to take two learning from wrong statement. What is wrong with the given information and which is correct for the given information. With this, we are completing Unit 9 solutions. Let's solve Unit 10 Artificial Intelligence questions. Definitions of which term in the options organized into following 4 categories, namely thinking humanly, thinking rationally, acting humanly, acting rationally. Which field is actually trying to mimic what humans do? It is artificial intelligence. Inside artificial intelligence, you have machine learning, deep learning, neural network. But this definition is about artificial intelligence. What is thinking humanly? It aims to model how humans think and make decisions. Thinking rationally means this approach focuses on logic and reasoning. Acting humanly seeks to create machines that exhibit behavior indistinguishable from human behavior. Acting rationally aims to develop systems that act to achieve the best possible outcome, or when there is uncertainty, the best expected outcome. Option number 3, artificial intelligence will be the right answer. Next question. Which one of the following is not related to the feed-forward networks on the backpropagation algorithm? Let's see about the functions given here. Boolean function. Neural networks can be used to approximate Boolean functions. A neural network can learn the logic of and or not. So this is definitely in neural network that applies to feed-forward networks. What about continuous functions? Neural networks are highly effective at approximating continuous functions. They can model complex relationships in continuous data. This is also related. What about arbitrary function? In theory, a sufficiently large and well-trained neural network can approximate any arbitrary function according to the universal approximation theorem. So even this function is involved in feed-forward network. So which is not related to feed-forward network here? Greedy function. Option number 4, greedy function will be the right answer. Greedy algorithms are a class of algorithms that make a series of choices, each of which looks best at the moment. But they are not a characteristics of neural network training. Whichever is best for that moment, that is going to be selected. How will you train neural networks without any logic or without any reasoning? You should have some kind of functions like Boolean or some kind of approximation functions to handle the data when they are passed through neural networks. So definitely greedy algorithms will not be a part of neural networks here. That's why we are marking greedy function as the right answer. They are asking which is not related to the feed-forward networks. When it is back propagation, it means some correction is going to happen there. Next question. The mathematical notation to describe logical entailment of a sentence. Alpha entails another sentence beta is. Alpha should be present in the LHS part and beta should be present in the RHS part. If that is the case, 3 and 4 are ruled out. What is this particular symbol? Alpha is a subset to beta. This cannot be definitely the notation for entailment here. So we can also rule out 2. Option number 1 will be the right answer. This will be the mathematical notation to describe logical entailment. What is this actually describing? The notation means that if alpha is true, then beta must also be true. It represents a logical entailment or implication where beta logically follows from alpha. Next question. Which of the following is not a component of the classic planning definition? So let's see about classic planning now. This typically involves the following components. Init, which gives the initial state of the system. Action, the set of actions that can be performed to transition between states. Goal, the desired state or set of states that the planning process aims to achieve. So we have init, action, goal. So which is not a component here? Option number 2, domain will be the right answer. If you take domain, you cannot restrict it to a particular state of a system. That's why domain is not a component in planning definition. Next question. What is the correct sequence of steps used by knowledge-based designing? Let's take the first step. Choose task domain or world to represent. This is B. This step involves selecting the specific area or environment that the knowledge base will represent. It defines the scope and boundaries of the knowledge base. What will be the next step? Select atoms to represent propositions of interest. This is C. Atoms or basic units of knowledge are selected to represent the specific propositions or facts that are of interest within the chosen domain. The next step will be tell the system propositions that are true in the intended interpretation or axiomatizing in the domain. The true propositions or axioms within the domain are communicated to the system. These propositions form the foundational knowledge that the system uses for reasoning. This is D. Next step will be ask questions about the intended interpretation. This will be A. Questions are asked to clarify the meaning and interpretation of the knowledge that will be represented in the knowledge base. Let's take this in the context of propositional logic so that you can understand the steps in a better way. This is just for telling you how this order happens. Let's take a domain in propositional logic, domain of integers or domain of real numbers. In that we have certain proposition statements. So that can be taken as select atoms to represent propositions. So this will be the next step. After that we are going to say the system propositions that are true in the interpretation. So here we are giving true or false value to the particular statement. So the truth of the proposition statement is given here. Ask questions about the intended interpretation means after giving the intended interpretation, you are asking questions over it. If you are able to get this order B, C, D, then definitely based on this particular interpretation, they are going to raise some questions will be followed after D. B, C, D, A will be the right sequence. Option number 2 will be the right answer. Next question. Which of the following are correct for the neural network? The training time depends upon the size of the network. The training time of a neural network is influenced by various factors including the size of the network. So A is definitely right. What about B? Neural network can be simulated on the conventional computer. Neural networks can be simulated on conventional computers using software frameworks like TensorFlow, PyTorch, and Keras. However, for larger and more complex neural networks, specialized hardware like GPUs and TPUs. GPUs are graphics processing units and TPUs are tensor processing units. They can be used to accelerate the training process. Even though it can be simulated on conventional computers, they say it will make use of some specialized hardware like GPUs and TPUs, which is not present in the conventional computers. So this is point A and this is point B. This is fine, but this is under question mark. What about C? Neural networks mimic the same way as that of the human brains. Neural networks are inspired by the structure and function of the human brain, no doubt. But do you think it is doing the exact mimic? I don't think so, because based on the training, neural network output accuracy can be improved. When there is something to be improved, you cannot say it is exactly doing what the human brain is doing. So in that way, I differ from C. So let's see about D statement. A neural network includes feedback. Some type of neural networks exist. Particularly, recurrent neural networks and feedback neural networks include feedback loops where the output of a layer is fed back into the network. To know about recurrent neural networks and to see the feedback loop, there is deep learning series in this channel, and in that you have one of the videos having the content of recurrent neural networks. But that video is available in Tamil language, but the content in the video is given in English. To understand the structure or to see the diagram of that feedback loop, you can definitely watch that video once. This allows the network to maintain a form of memory and handle sequences of data. So D is also true for sure. As per the official answer key, we are going with option number 2, A, C and D only as the right answer. Though it can be simulated due to certain specialized hardware, I think they have ruled out this particular B statement as incorrect for neural network. So taking that into account, we are actually ruling out option B and we are going right with option C. I don't say that C is false. It is trying to mimic the same way as human brains do. But when there is a difference between the expected output and the actual output, it is not still completely doing as humans is what I wanted to tell you. Next question. The kind of symbols for basic syntactic elements of first order logic are: constants are symbols that represent specific objects in the domain of discourse. So constants are there. Predicates are symbols that represent properties or relations between objects in the domain. Predicate is there. Functions are symbols that represent mappings from a set of objects to another object within the domain. Function is also there. A, C and E only are included here. Option number 3 will be the right answer. What about domain and temporal? The domain refers to the set of objects over which the variables in the logic system range, but it is not a symbol within the syntax itself. That's why we are ruling out domain. What about temporal? Temporal aspects relate to temporal logic, which extends first order logic to include temporal operators, but temporal is not a basic syntactic element in first order logic. They say it extends, but it is not basic. So we are even excluding temporal. Next question. Match the list 1 with list 2. Decision tree, supervised learning, artificial neural network, instance-based learning are provided in list 1. Delta learning rule, self-organizing map, C4.5 algorithm, non-linear regression algorithm are provided in list 2. The C4.5 algorithm is a well-known algorithm used to generate decision trees. A will be mapping to 3. A3 is available only in one option. Non-linear regression is a method used in supervised learning to model the relationship between inputs and outputs. B will be mapping to 4. The delta learning rule, also known as the least mean squares rule, is often used in the training of artificial neural networks to update the weights. So we can map C to 1. What about self-organizing maps? They are a type of unsupervised learning algorithm used in instance-based learning to produce a lower dimensional representation of the input space, often used for clustering and visualization. We can map D to 2. A3, B4, C1, D2. Option number 3 will be the right answer. With this, we are completing Unit 10 solutions.